one's much easier to find than the other
This is
one.
a pulse
And this
here.
one you turn off and on.
So all of them off. Okay.
Yeah, these are every output is turned off.
Okay, and I'd assume VGA is fine.
We can go to VGA.
I mean, like if they're outputting VGA.
Oh yeah. No
Okay.
one's gonna do a high def on
No. Okay,
on
cool.
that.
All right. So we gotta wait for audio in this room.
I think he's calling you.
What's up? Test, test. 1, 2, 3, 4, 5, 6. It might be muted on the board. Are you getting signal? 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2. You good? Graham, can I get your cell in, please? Of course. Test, test. 1, 2, 3, 4, 5, 6. Test, test, 1, 2, 2, 2, 2. All right, so we got to raise it on the camera a little bit. 1, 2, 2, 2, 2, 2, 2. There's going to be a little bit of a delay. Test, test, 1, 2, 3, 4, 5, 6. Test, test, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Could you just set the MacBook to 50% audio? Yeah, so we need the audio guy to lower it then. It's at 50%? Okay, so they're sending it to me too hot. I think they probably have it gained too high. Two, 2, 1, 2, 3, 4, 5, 6. Test, test. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Test, test. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Testing. 1, 2, 3, 4, 5, 6. Okay. So do we have?
Their house amps need to be turned up so that you don't have to gain up so much. Because when you're coming out, you're right into the computer with the gain on the mic, it's so blasted up.
Yeah.
It's just coming in.
Okay. Is it in sync though? 1, 2, 3, 4, 5, 6. Test, test. 1, 2, 3. What's that? Oh, there's a delay. Okay, so I'll just do 5, 4, 3, 2, 1. 4, 3, 2, 1.
Yeah, it's in sync on itself. Of course, it's delayed.
I know. Yeah,
Yeah, and then it's like, yes, it's not
I know you're hearing it.
between computer.
Okay.
It's a little out of focus, but that's just me.
Yeah.
So it sounds like it's, but see, you get it in, like I said, the amplifiers in the house. Oh, wait, it's right here. Yeah, see, here's what it is. This is where you normally have it from zero. And you have it all the way here. So it's all the way here, then it sounds great.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it coming through on my laptop there? 1, 2, 2, 2, 2, 3, 4, 5, 6, 7. 1, 2, 3. Is that hitting the laptop? One, two, three, four, five, six, 7, 8, 9, 10. Test, test. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Test, test. 1, 2, 3, 4. Oh, okay. Let me know when you're ready for me.
Testing 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. All right. It's cut off. It's now not going through. Okay, got you. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Testing. 1, 2, 3. 1, 2, 3. Testing. 1, 2, 3. 1, 2, 3. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3. Testing. Testing mic. Testing podium mic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, good evening, everyone. I'm here to give the presentation today for JavaOne and the Oracle. Java is the #1 choice for developers, 97%. 13 billion devices run Java. Let's see. Connect via Wi-Fi hotspot. Mobile application. Download Oracle Open World San Francisco. %, of enterprises, JavaOne is one of the best choices. Oracle, what else could I say? The mobile application download for Oracle. What's that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. Welcome to Oracle. This is the Oracle convention. 9 million people use Java worldwide. Java devices outnumber people on Earth. 97% of enterprise desktops run Java. 13 billion devices run Java. Java is the #1 choice for developers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Testing. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see. 13 billion devices run Java. I'm not a loud person. Okay, this is the presentation here for Oracle and JavaOne. #1 development platform now in the cloud. Java devices outnumber people on Earth. 97% of enterprise desktops run Java. 13 billion devices run Java. Java is the #1 choice for developers. 9 million Java devices worldwide. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep.
All right, good morning, ladies and gentlemen. I'd like to present something right now, just to let you know this is going to be what it's going to like. So how is your gain structure in the room looking on that microphone? That's maybe about what it was before. This is somebody who's actually talking, presenting, and you're going to end up with somebody who talks like that, but there's not much you can do about it, but you just turn it up a little bit. But this should be our gain structure, and is that seeming about right now? I can't hear from this far away if there's an answer, but is that all working like it's supposed to and such? Check. I can't hear what's going on. This should be where we were before. I can't hear. I'm not hearing what you're saying. We're good? Okay, let me go to a table mic. This is 3 maybe. I'm not, depending on how they set it up, but I always set it up from the house. But this is somebody talking and not talking very loud, but I'm hearing it in the room and it's sounding sort of like the way, and you should be getting it at the camera about the same level, about the right level and such like that. Because I'm not eating the mic, I'm a little ways away, I'm giving you something to work with. So, all right, if we're good? Camera level's good and computer level's good? Okay, cool. And here's mic middle. I'm about the same distance in volume. And here's other mic. I'm trying to be the same distance, same volume. Cool. Great.
Check 1, 2, 2, 2. Hey, 1, 2. Check 1, 2, 3, 4. Hey, 1, 2. Check 1, 2, 3, 4. Hey, 1, 2. Check, check. Hey, Lori.
We don't have them in the advanced. No, the advanced is, I'll show you what I have in this one. It's just the, yeah, the zero. Yep. this clicker work? Yes. We got audio? Okay, good. Tell me when. We ready to go? Okay. So welcome to JavaOne, and welcome to this session on JDK 9. My name is Alan Bateman. I'm working on the JDK for a long time. For the last 2 years, I've been working with Mark and others on the module system for JDK 9, so that's what we're going to be talking about in this room today. So we have 4 sessions we're going to be sticking in this room for. This one is just going to be a preparatory talk about what you might expect moving from JDK 8 to JDK 9. And then we're going to get into the module system and have an introductory talk, an advanced talk, and Alex Buckley is going to go do a really, really advanced talk under the hood later on today. All of these sessions are in the same room. If you're interested in doing something hands-on with the module system, then come back here for 8:30 tomorrow morning. We're going to have a hack session. That's going to be an informal play around with the jigsaw builds, question answers, traditional kind of tutorial BOF style. Okay, so I want to start by just getting a feel for what people know about JDK 9, and maybe start by asking what version of the JDK folks are using already today. So hands up who's on JDK 8 today? Which, that's really good. That's most people. Who's still back on JDK 7? There's a few people. JDK 6? Should I go back any further? So anytime we do this, we often end up going all the way back, and there's always one guy that'll put his hand up to say he's still on 1.0 or 1.1. I won't do that today. So I'm curious, another show of hands as to who has been tracking what's going on in JDK 9. I've been looking at the JEPs, and okay, that's good. Who has been trying out the JDK download? So we produce a build every week. A couple of hands, maybe 10, 12 hands. Okay, that's good. Who has been brave enough to try some of the jigsaw builds, which are essentially the JDK 9 builds plus the module system? Okay, 2, 4, 5, 6 people maybe. Okay. All right, so we'll be talking in this room in the introduction advanced session all about jigsaw, so if you want to hear more about that, come along. So just at a high level, just some goals about what JDK 9 and Project Jigsaw are all about is it's all really about making the platform more flexible and scalable. It's all about scaling down to small configurations, to containers that can run in the cloud and so on. It's all about improving the security and the maintainability of the platform, and also for library developers. So lots of high-level goals here, because it'll be great if, as a library maintainer, to be able to encapsulate your APIs and be sure that there isn't any other libraries or applications making use of them. So just some background on we call it the modularity landscape. So there's a JSR going on at the moment called the Java Platform Module System. Mark Reinhold, who's down on the front here, is leading this JSR. That's JSR 376. That's going on in the Java community process. That started earlier this year and is actively working through some of the big issues and the design of the module system. There will be another JSR for Java SE 9 itself. It's too early to start that. That will cover all of the contents and all of the smaller features that will be going into Java SE 9. There's a bunch of what we call JEPs. These are Java enhancement processes. This is the way we work within OpenJDK. This is where we work on the implementation. So I assume everyone knows that the implementation is all done in the OpenJDK project in the open. So there's a bunch of these JEPs. I know it's a bit confusing to have JSR numbers and JEP numbers. So the JEP numbers that we have that cover things module related are 200, 201, 220, 260, and 261. 200 covers the modular JDK. So if you've been to JavaOne before, you'll have seen Mark and others show various spaghetti diagrams of the JDK. So the spaghetti diagram is something that we've been working to clean up over the last couple of years. That has been a really, really long background effort to get it to a sensible and clean module graph. That has taken a lot of effort. What we've done then is we've translated that module graph into the source code layout and the build for the JDK itself, and that's what JEP 201 is all about. It's not something that you actually see if you're just using the builds, but if you're working on the JDK itself, then that has a big impact on the way you work, because it's how the code is organized, how it's built, and so on. And so that's more internally looking. 220, then I'll be talking a little bit about this. I have a couple of slides on this today. This is about changing the output of the build and what we know today as the JRE and the JDK, and how they're actually laid out. And as I said, I'll cover those. 260 deals with the encapsulation of internal APIs. I have a couple of slides on that today. And 261 is really dealing with the implementation of the module system. We'll be covering some of that today. Okay, so just some background about some of the internal APIs. So I just want to give a couple of background slides before going through at a high level what the changes are that are proposed for Java C9 and JDK 9. So the first thing is we'll just talk about the APIs, and anyone that's used the Java C APIs or even the EE APIs will know that they all are organized into the java.star package or the javax.star for typically, historically, for extensions and EE APIs. A lot of javax.star APIs have worked their way into Java SE over the years, as well as Java SE grew. There's then a bunch of JDK specific APIs, and this is totally confusing for most people. There are some JDK specific APIs that are documented, they're supported, and then there's a whole bunch of them that are JDK internal. No one's supposed to use those. If it's got internal in the name, then it probably means that you shouldn't really be using it. You're on thin ice, because it could change at any time. And then there's all the unsupported APIs. So some of these ComSun APIs and JDK APIs that I mentioned earlier, they're in the unsupported bucket, but very, very difficult to know which is in which bucket. But the Sun.star APIs, that was very, very clear. They are always being unsupported. And so Mark actually dug out a web page, which it's not quite 20 years old, but it's close to it. I don't know if anyone will actually recognize this. I'm sorry for folks at the back, you're not going to see the details on all of this, but this is one of the documentation pages from the JDK 1.0, 1.1 documentation bundle. And it explains java.star is the APIs you should be using. Sun.star, totally unsupported, can change at any time. So I've just highlighted just part of the wording around that. And right down the bottom, for those at the back, you won't be able to see it. It's just the date. This is 1996. So we've been warning in the documentation about this for a long time, but who reads the documentation? Now, the compiler has been warning about this since JDK 6, and I'm curious who has actually ever, hands up, who's actually ever seen a Java C warning about using an internal API? Oh, a few people have. Okay. Hands up who ignores Java C warnings. Right. Okay, so I just want to talk about just general compatibility. This is just a couple high-level slides before we get into things. So the general sort of compatibility goals are, if you run on a particular version and you're only using the supported APIs, then you should be able to run on N+1 without any changes. You shouldn't even have to recompile. I think generally we've been quite good at that. Some areas in the past we've been a little bit poor about some of the compatibilities between releases, but a lot of people have learned a lot about compatibility over the years, and I think things have improved quite a lot. So just to say a point there just about supported APIs, there is a process for removing supported APIs. It's a process that isn't used all that often, but given advance notice in a major release, then it is actually possible. And 9 will be one time where we will exercise this right to remove some APIs. These APIs I'll talk about later on in the slides. These have been deprecated for some time. We've warned about it in documentation going back for many, many years. So there won't be too much of a surprise, I hope. So just about managing incompatibilities, and there's a whole spectrum of compatibility issues that you get into: API compatibility, behavioral compatibility, and so on. If you ever get a few minutes, is Google Joe Darcy's blog about compatibility and incompatibilities, and it's a very good write-up because he actually puts everything into different buckets and explains the landscape there quite well. So anyone that's actually working on a change, they have to always consider whether there's a possibility of breaking something. Is this going to break someone from when they try to recompile their code because it's a source incompatible change? Is this something that's going to break someone because a binary incompatibility issue or some other behavioral change? There's all these things that you actually need to think about. And everyone working on the JDK, and this has really, really helped since we've moved to OpenJDK because there's more eyes on the code and there's more people thinking about what the impact of a change might be, is you always have to judge the risk. And when there's a possibility that you're going to break something, is finding data to back up what you're doing or to support or break your case for whatever change you're trying to do. We've always tried to communicate early and vigorously. So when something needs to change to get some API to work the right way, or then it's documented that this is going to change, and there's always advance notice on things. Let's see, a couple of other things is when we're moving unsupported APIs, then people do actually spend some time thinking about what the impact is. There's a whole bunch of interesting and very tempting classes in sun.misc that people tend to use. And we have been very, very careful not to remove those over the years. Yes, they're unsupported, but we know that if we start removing some of these things or changing them, then it's going to break somebody that depends on them, because we've never enforced and never had proper encapsulation of those sun internal APIs. And when we do make changes that are incompatible changes, there's typically workarounds. My guess is that most people won't realize that there's a whole bunch of these weird properties around the JDK for restoring old behavior. So when things change, maybe in some update release because of some security release because of some issue, then sometimes you have to make changes. And well, we know that some people might depend on this behavior. So there's typically some property to keep existing code going. The other thing is release notes. I'm curious, actually, maybe a show of hands as to whoever actually ever looks at the JDK release notes. Oh, there's a few people. Okay, that's actually more hands than I expected. There's an excruciating amount of detail goes into some of those release notes, because we're tracking all of the time all of the changes that are actually going on. There's almost a little essay written up for some of the different changes, and they eventually work their way into release notes. But it's often years afterwards that people actually, when they finally upgrade, there's some change. They write in Stack Overflow, I've got this problem, and then, oh, well, this is actually something we've known about, it's been documented. So what I notice is a lot of people don't read the release, and that's very understandable, because you just want to be able to upgrade and not have to spend time thinking about compatibility issues. Okay, I want to talk just about some of the incompatible changes in 9. So this is sort of a high-level list of the things I want to spend time on. I want to talk about encapsulating the internal APIs. I want to talk about removing a small number of methods and JCP supported APIs. I want to talk about the structure of the JDK, talk about removing a couple of features that people might not know about. I want to talk about the version string change and also the underscore. So most of the time I want to talk about internal APIs. So I'll start by showing this little graph of, this is an analysis of a number of libraries. This is the number of Oracle products and a bunch of open source libraries. There's about 110 used in this particular analysis. So what we actually see here is there's a small number of internal APIs that are used a lot. So there's there's 100, 125 usages of some particular internal API. And then it drops steeply then down, and we see there's like 25, 20 usages of some other internal classes, and then there's this big long tail of up to about 700 different internal APIs that are used by the libraries in this analysis. Now, I'm curious, who can actually guess what it, you haven't seen you don't have the list of libraries that are used here, but I'm curious if anyone can actually guess what might be at the top there with 100, 125 usages. Okay, I heard unsafe by many, many people. Well, in this analysis, it turns out not to be the case. SunMISC base64 encoder, and it turns out that SunMISC unsafe only made it to number 2 on this list. If I actually went down and showed you the one that's underneath that, about 80 or 90 usages, just on this sample, then it was actually SunMISC base64 decoder. So this one is a little embarrassing. We did finally introduce Java Util base64 in Java C8, but it's 10 years too late. This is something we should have put in a base64 encoder decoder a long time ago. Okay, so we've got all the, we know that there's all these usages. Some are used a lot. There's this big long tail. What we've done, and you can mark mostly for leading this effort here, is to try to categorize what these internal APIs are. And there's essentially 2 buckets. There's the non-critical APIs and the critical APIs. In the non-critical APIs is they don't show up on that analysis. Or if I download all of Maven Central and I look at the usages, I don't see them there. So there's no evidence that there's a lot of internal APIs are used. It's also the bucket for a whole bunch of APIs that are only used for convenience. And I would put base64 in that. There is no reason to ever have used SunMISC base64 encoder. It was just a convenience. They're there. Old code tends to use it because it was just useful to have it's just there. Then there's the critical APIs. And this is the functionality that would be difficult or if impossible to implement outside the JDK. So that's where you see SunMISC unsafe. That's where you see a couple of other critical APIs. So what I want to talk about a bit is the high-level proposal that's in JEP 260. So I mentioned JEP 260 at the beginning of the talk and the high-level proposal within this JEP is to encapsulate all the non-critical internal APIs by default. So non-critical from the last slide is all the internal APIs that are not showing up in any of these analyses as being used, and they're also the ones that people just use them for convenience. We're also proposing in this JEP to not encapsulate the critical internal APIs. So that's the unsafe, and I'll give you the list of what the current proposal is in a few minutes. Instead, the proposal is to deprecate them in 9 and then provide some kind of replacements and plan to remove them in the 10 timeframe. This is going to be really, really difficult. Some of these internal APIs, how we're going to have supported implementations or supported APIs. I'll give you a reference later on in the talk to Paul Sandus's talk tomorrow on SunMISC unsafe, because that is where the hardest problems are, and it's a problem we've been chipping away at for a long time. So what are the critical APIs that we're talking about not encapsulating in 9? Well, this is the list. SunMISC unsafe, some of the signal handling, SunMISC cleaner. I don't know if anyone will admit to using that here and how they use it. And then there's a few. There is a JEP at the moment to introduce a stack walking API. It's possible that we may not have to that the reflection get caller class may not be needed in 9 if there's a supported API. We'll have to see. And then there's a bunch of serialization libraries and things that use the reflection factory in order to instantiate objects without running constructors and so on. So that is what the reflection factory is. So this is the proposal that's there in the current JEP. There's some early stages for refactoring to be able to move in this direction. What we've asked is if there's things to add to this list, then come along with a justification and some data to support your case to get added to this list. So now what I want to do is, given this characterization, is go back to the graph I had a minute ago and list down all of those internal APIs that came up in that graph. And these are now color-coded. Now for those in the back, now is a good time to bring out your binoculars. And my apologies to anyone that might be colorblind. So what we have here is color-coded the names of the classes and so these are the internal APIs that were used by that set of 110 different libraries. It's hard for me to even read it. Okay, so the ones that are in this orange are the critical APIs. So second from the top there, you'll see Sun, Misc, Unsafe. There was 102 usages in that particular data analysis. You'll see Sun Reflection Factory there, and there's a few more of them down there. So they're critical APIs. They will not be encapsulated in the 9 time frame. Now then what we see is the ones that are in this purpley color. These are non-critical APIs. There is replacements for those in either 9 or older releases. So right up the top we have our Sun Misc Base64 encoder. Third one down there is decoder. They're in purple because it's hard to read this, I know, because there's too much on the slide, but it has up there R8 beside it. There is actually a supported API for Base64 encoding and decoding in JDK8. There's no reason for us to continue to have a Base64 decoder in Sun Misc anymore. Just on that particular one is we gradually replacing all the usages in the JDK anyway over time, so we won't need this. So there's a bunch of these that are actually in red, which don't fit into any of these buckets I've talked to today. These are really just non-critical APIs where there is no replacement planned. So there's a whole bunch of these things. In this analysis, you can actually see that there's from where I'm standing here, I can see things like COM, Sun, Org, Apache, XPath, internal. So there's a whole bunch of things that are actually making use of internal classes within the XML code. So there's no replacement plan for those. So this is worth looking in more detail sometime, but can't really spend time on it today. Okay, so what I do want to talk about is how do you find the usages of these internal APIs in your own code? So we have a tool in JDK8, and it's improved in 9, called JDEPs. I'm curious for a show of hands as to who has heard of JDEPs. Ooh, maybe 10, 12 people have tried it. Okay, so JDEPs is a simple command line tool that does static analysis of your of a bunch of jar files, and it tells you what they depend on, what classes they use. It'll warn you whether you're using internal APIs. For a small number of cases where there's supported replacements, it makes a suggestion as to what the replacement is. So this is a very, very useful tool to have. There's also a Maven plugin that you can actually integrate into your project to run in your build, which is quite useful because you can get it to do the static analysis on your own code, or you can actually get it to look at all your dependencies as well to see whether they have any dependencies on internal APIs. So as I said, this is in JDK8, so the tool has been there for a while. We did this as part of JEP 162 in the 8 time frame, which was, JEP 162 was a big bucket of prepare for modularization tasks that we wanted to get done, and making the tools available was one of those things. So here's a little example. I haven't showed the output. I'll show the output on the next slide. So I'm using one of the Glassfish jar files as an example. I'm not picking on Glassfish. I just happens to be Glassfish is one of are good friends of ours, and they have a good plan for removing their dependencies on internal APIs. So I don't feel too embarrassed showing one of their jar files. So I'm running JDEPs here, and the option I'm using is -JDK internals. JDK internals is the option to JDEP to report any usages of JDK internal APIs. So I'm running it on one of their jar files, the security jar file, and let's see what the output is. Again, my apologies for this, the font is small here, but so I'll have to just talk through it. So what we're seeing here is it's listing out a bunch of classes that are in this Glassfish jar file that have dependencies and have static references to sun.star APIs. In this particular case, I think what's happened is this is an internal security framework in the JDK, and the code in this jar file is helping itself to those classes. So we can see here the first one, we see a com, sun enterprise, common, blah, 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 and it's making use of sun security util object identifier. And then I go down a bit, and I see it's making use of sun security x500, x509 name, and there's a bunch of other sun.star security PKS11. Okay, so JDEPs is telling me, is warning me about that, and right down at the bottom, and it's just making a suggestion here, is this X509 name actually has, X500 name has a supported API, and that's X500 principal, and that's there since JDK 1.4. You may want to look at considering using that instead of the sun.star class. So this is useful because you can actually run this on your own code and get an idea what exposure you have to sun.star APIs. So let's go and see what happens when I run this code on a Jigsaw build that has the module system and strong encapsulation. What is going to happen? This code is going to run. It's going to attempt to make use of the sun.star API. What will happen? And this is what we get. This is a scary exception. We're close to Halloween, so I don't feel guilty showing scary exceptions. And by the way, I have a number of scary exceptions to show. This one is an illegal access error. And that's bad when you see an illegal access error. For those at the back, I'll just read it out. We have this class com, sun security enterprise security provider, policy wrapper, ignore the unnamed module. We'll talk about that today in the other sessions. Cannot access sun.star security provider policy class in module Java base. Java base we'll be talking quite a bit about in the sessions today. That's the actual core of the system. That's where this policy file class exists. And then the rest of the exception says that sun security provider is not exported. So this is just saying the classes in this package are fully encapsulated in the base module. It does not export them. Therefore, this class cannot use them. So it fails at runtime. I have not attempted to recompile this Glassfish code. I've just attempted to. It's built on 7 or 8. I've tried it with Jigsaw builds. It fails at runtime. I'm now going to show another example. This time I'm picking on Gradle, and my apologies if anyone from Gradle is in the audience. This is one where we attempt to build just some Java library with Gradle, and I'm using 2.7. I know there's a 2.8, and it fails. And this compile Java task fails, and I get this error. Could not create an instance of type com sun tool javac API javac tools. Now, when I look at that, that looks to me that there's some problem with it loading the compiler. It's not very clear, but the try message that Gradle outputs tells you rerun it with the stack trace option to get more information. And okay, I will do that, and we'll see what actually happens next. Okay, I'm going to run it with the stack trace option, and I get more details. Now, there's actually, I have not included all the details of the output here because there's a big, long stack trace. I've actually skimmed all the way down to the exception cause. This time, I'm getting a Java lang illegal access exception, which is the core reflection equivalent of the illegal access error that I had in the previous slide. So let's read on the exception more. So we've got our or Gradle internal reflect direct instantiator cannot access class ComSun tools, JavaC API, JavaC tool, and module JDK compiler. Okay, because module JDK compiler does not export ComSun tools API, sorry, JavaC API to. Ignore the unnamed, we'll talk about that in the other. Okay, so what we have here is, there's obviously some code in this Gradle JavaC compile task that is making use of this unsupported API. Now, normally when you use JavaC, you use the JavaX tools API, but for whatever reason, this is using the ComSun API. So this is what happens when you attempt, and this is with core reflection because it's an exception, not an error. This is actually what happens. Yeah. I don't like showing scary messages without also just adding that we should not panic. There is a workaround to this. We can't just, here we are, the Java platform's 20 years old, coming along with strong encapsulation and module boundaries after 20 years, you're going to break code. So we have to be careful, and there is a get out of jail card, which is a command line option that will allow us to export these otherwise unexported APIs. So I'll go back to the Glassfish example, and Glassfish example was using a whole bunch of Sun security classes, and the command line option that I can use to export those internal APIs is called xadd exports. You basically give it a list of what modules, what API packages you like to export. Ignore the all unnamed. We'll get into that later on. But just think about it. It's exporting it to all the code on the class path. And I can list down any of these API packages. And that is our way to get existing code using internal APIs to work with modules without changing that code. Now, I've picked on Glassfish a bit here, and as I said, they are our friends, and it turns out they have been putting a bit of work to understand all of this. They've got about 10 issues in their JIRA to track the fixing these dependencies at some point. So I've just, for those down the back, this is just a screen capture of their JIRA, which is this particular issue with the policy file, because that has to get fixed. And they have a bunch of other ones as well for all the issues that we know about. So just the option again, just to see what it is. For xadd exports, just think about it as breaking encapsulation. This is what the syntax is. The value of it is the source module, the package, and who you're going to export it to. It looks a bit gross there because I've listed down 3 or 4 packages that are being used, but that's how to get all of those API packages to be exported and allow that code to work unchanged. Okay, so that's a summary of this, talking about the internal APIs. I want to get back to the original agenda items. The main thing is that we've been talking about modules for a long time. We've been talking about encapsulation for a long time. We're finally getting there. It's going to be a little bit scary doing this transition, but we have workarounds, and we can keep existing code working until it actually is updated. Okay, so we talk about some of the other changes. So I'll move on and talk about the APIs that we want to remove in 9. And this is the list. It's only 6 methods. We've been warning about these for quite some time. There's 2 methods in JavaUtil logging log manager. They have better replacements in 9. There's 4 methods in the Pack 200 classes. We don't expect this will be a huge, big disruptive change. As I said, they have been flagged for removal for quite some time. The JSR for JavaC 8 listed them down as for possible removal. We have yet to find anything using the Pack 200 methods. It does not appear to be all that used. These methods for adding property change listeners to the Pack 200 was really just for deployment type tools to be able to track the packing and the unpacking. We've yet to find some usage. When we search Maven and we search other places and other big code corpuses to find usages of the JavaUtil logging log manager, we found very few, less than 5. So that's actually quite good. It's not thousands of libraries using it. It's really, really tiny. And as I said, there is a replacement to these. Okay, I want to move on now and just talk about the binary structure of the JDK and the JRE. Now, I'll start from the bottom point. This is something that is in the JDK 9 builds since last year. This is a disruptive change for tools. It's a disruptive change for compilers. And we knew this would be. So that was one of the motivations for getting this into JDK 9 early. So for those that put your hand up using JDK 9 and trying out the JDK 9 builds already, then you're actually making use of this already. So there's a bunch of motivations for this, but one of them is we wanted to adopt a much more efficient way of storing the classes and the resources in the JDK. We've always, well, since JDK 1.2, we've used rt.jar, and that is not a very efficient way for storing the classes. There's a whole bunch of optimizations that we can actually end up doing if we can move to a more efficient format. Moving to modules will completely blur the historical distinction between what we know as the JRE and the JDK. If you sit in some of these sessions today, you'll actually see we'll be using a linker tool to produce custom runtime images that are composed of modules, application modules, third-party libraries, JDK libraries. We will combine those together with a linker to produce a custom runtime image. The historical layout of what we know as the JRE and the JDK don't fit very well with that. So that's part of the motivation. It's not technically an API. It has never been a supported interface to go squirreling away in the JDK image and find, there's tools.jar, I'll have a rummage around in there, or there's rt.jar, these other configuration files. That's never been a supported interface. It's not really an API. What we have done, and this is for the first time ever, is actually provided now a supported way for tools and compilers and IDEs to be able to get at the classes and the resources in the JDK. So we're going from a sort of yes, this is the way things work, to here's a new way that you can actually do things. So that will be good going forward. But this is a disruptive change for a number of tools. If you want to read all of the details of this, then JEP 220 is the JEP to Google. Okay, so this is just at a high level what a JDK looks like today. So this is the JDK image. It's the one that has the tools, Java-C, and so on. I don't know the full history of this. Mark probably will remember. This I think came about by accident back in the JDK 1.2 timeframe. The JRE, or the runtime, has its own bin directory with Java and various other launchers in there. It has the lib directory with rt.jar and a bunch of other jar files. Then the JDK encloses that and also introduces a top-level bin directory and a lib directory. And the runtime in the JDK was always been in the JRE directory. So what does this mean? Well, it actually means we have two bin directories. If you actually look at the JDK, we either have two copies of some of the launchers. This is really, really odd looking when you see it for the first time. There's a Java here and there's a Java here. Which Java should I use? We've got the tools.jar up in this lib directory, and then you've got another lib directory down here. We've managed to live with this arrangement for quite some time. And this is what's actually changing. And this is what the new layout is. It's very, very simple. As I say, completely blurs JRE and JDK. There's a bin directory where all the tools live. That's where you'll find Java. That's where you'll find Java-C and all the other. Any of the configuration files. So this is another big confusing part of the JDK and the JRE layout is there's a bunch of files in there that have configured the runtime. The security policy file, for example. Well, when you look down through a traditional JDK and you start looking down in the lib directory, there's a whole bunch of other files as well. Can I change that? Am I allowed to change that? Will it get overridden? Question marks over every one of those files because we've never properly documented what makes sense to edit, what is not meant to be edited. And so there's some documentation pages that do cover this, but not in a very comprehensive way. So what this new layout does, and this new runtime modular image is anything that is customizable is moved into the conf directory. All user editable configuration has moved into to the conf directory. The lib directory, yes, there's a lib directory in there, but I'm not saying what's in it, because we need to be able to change that going forward. So I talked about having a more memory efficient and performance efficient, just a more efficient layout for the classes and resources. That's where we'll be able to store those classes and resources, any other optimizations, and we need the flexibility to be able to change that at any time. So that disappears into the lib directory in some internal format. So the main things looking at this layout is there's no top-level JRE directory, there's no rt.jar, there's no tools.jar. Now you can see why this is a disruptive change, because there are tools out there that they look at Java Home and they'll have a look, oh, is there a JRE directory in there, so that it can tell whether it's running on a runtime or a JDK. It starts looking for rt.jar because it's a compiler. It needs to be able to find all the types that you want to reference. Well, there's an rt.jar. So the API that we have for those type of tools is a file system API. So we have a proper file system API in the platform since Java C7. That's a pluggable API, and there is a file system provider that can be used by the tools to access the runtime image. And the good thing about it is it allows JDK n-1 to access JDK n. This means that the IDEs or the tools running on a JDK 8 can access the runtime image that is a 9. So this is really important, because a lot of the tools that you use, the Eclipses, the IntelliJs, the NetBeans, and so on, when you run them, they're running on a different JDK to the JDK they're actually targeting. Okay, I'll move on and just talk a bit about a couple of things that have been removed. Does anyone know what, hands up actually, who knows what the endorsed standards override mechanism is? 3, 4, 5. Okay. This is removed, as is the extension mechanism. Who knows what the extension mechanism is? Yeah, 4 or 5 hands as well. Okay. The endorsed standards override mechanism was all about being able to replace or upgrade components that are in the JDK or Java SE. It's typically what the app servers use so that you run with an upgraded version of JAX-WS or JAX-B or the common annotations. It's not something you typically have to do with your in your own application and libraries. There's also a bunch of standalone technologies in the JCP that they work to their own schedule. They don't work to the same schedule as the JDK, and some people need to run with upgraded versions of those. So the endorsed standards override mechanism was the mechanism for running with newer versions of those standalone technologies, and also running with newer versions of certain endorsed standards, the OMG Corbis specifications, the W3C DOM API. So there's a couple of these things that have worked into the Java C APIs over the years. You need to be able to run with upgraded versions of them. This was the mechanism to do this. The extension mechanism was a real misfeature, which was allowed libraries to basically be just dumped into the JDK or JRE image and being picked up and used and made visible to all applications. Very, very problematic mechanism. These things are completely removed in 9. We've warned about them in the 8 time frame. There's a much better mechanism in the Jigsaw builds for this, which is called the upgrade module mechanism, which allows components to be replaced complete module at a time, and they completely shadow then the version of the module that is in the runtime image. So that actually works out quite well. Okay, so a couple of other changes just to mention is this is only just a small list of them. If you go to JEP 261, we have a comprehensive list of the things that we know about, because we've been thinking about compatibility for a long time. So the first thing is and we've run into a couple of cases of this where we found code that assumes that the application or extension class loader is a URL class loader. So this is a very implementation-specific assumption that they're actually making. So they get the system class loader, blindly cast it to the URL class loader, and attempt to do something maybe to extend it at runtime or whatever. So I'll show an example of what this means in a few minutes. What we know as the boot class path is completely gone. Options to replace the boot class path in the compiler, to prepend and override classes, they are all gone. There's much better ways to do this with modules. The system properties that back those are also gone. So this will be something that some code will run into, but we'll just have to get over all those issues. There's a bunch of other things, but Google for JEP 261, right down the bottom of it, we have everything that we know about so far. So just to give an example of this is, here's another example on Gradle. My apologies to anyone that might be from Gradle here. It's just picking a few random things that we know would be impacted by this. So this is running. This is an exception running in Gradle where I get this exact class cast exception because there is some code in there that is blindly casting the class loader to JavaNet URL class loader, and it's not an instance of that anymore. This is an implementation assumption. Now, this is one that the Gradle folks are aware of. They've an issue tracking this, and it's admitted this is a hack. It's to work around command line limits. There's a better way to do this in 9 with what's called arg file support. So in time, we'll see. We would hope that they would make use of that and then get existing versions or getting newer versions to work. Okay, one other thing actually, I realize I'm showing a couple of scary messages here is every single major release we do a lot of implementation changes. So irrespective of modules, irrespective of encapsulation, there's always changes going on. And it always tend to trip up some code that makes implementation assumptions. It's just the way things are. This is one we had to get through this transition. This is another legacy thing that goes back to the 1.2 timeframe. So I just wanted to mention this one as just this is just one of these things that happens when you make implementation assumptions. So I have a couple of slides here on the versioning string scheme. That's the final thing that one other thing after this I want to talk about. And I'm not spending time here on the version string change. I see Iris Clark in the audience there. You can track her down and ask any question you want about this. I mostly just want to create awareness in this session that this is something that's going on in the JDK timeframe. So maybe another show of hands because we haven't done that for a while. How many people think that the JDK versioning scheme is totally confusing? No, I'm surprised because there's a motivation in the JEP that I'd actually like to read out because I always puts a smile on my face. Is which release contains all the most recent security fixes? JDK 7 update 55 or JDK 7 update 60? It looks like update 60 is 5 releases later than 55, so therefore it must include more security fixes, right? That conclusion is incorrect. These 2 releases contain both exactly the same security fixes. And it goes on then to explain how security fixes, when they come out, increment the version by 5. Updates increment the version by 20. This is really, really confusing. So this problem is finally being tackled to come up with a new scheme for versioning the JDK. So JEP 220 is the one sorry, 223 is the JEP to Google for that to get all of the details. There's changing the version scheme will impact any code that looks at java.version, that looks at some of the properties. It may or may not impact them. It depends how they actually parse the version string. So it's just to create some awareness of this. This version change is not in the JDK 9 builds yet. I'm not sure exactly when it will go in, but it's just something to be aware if you're using the JDK 9 builds to try it out once they change. So this is taken from the JEP, showing the old and the new. So we can see here when JDK 9 goes out, in the old days it would have been called 1.90 and dash whatever the build number is. It will actually change to be 9, and then there's a long version that has the build number without the B in there, and the short version is just 9. So best to actually just Google the JEP and read the details, because it has the before and after, or the old and the new, and it actually makes it very, very clear. The system properties is the one to keep an eye on. If you have any code that is looking at java.version and is parsing that string, are you parsing it correctly? Because the big thing is after 20 years, 1.0 is gone. So for 20 years, we've gone from 1.0 to 1.1 and all the way through to 1.8. The 1.0, it's very, very clear now in 2015 that the major version is actually what we've been putting after the 1 in previous releases. So the main thing, and there's a couple of examples in the JEP, and I'm sure if anyone has any questions, go to Iris. She will has data on things that she has tried so far, because she's been trying out or other people have been trying out different libraries and products to see what might break. And I think there's only a very, very small number of cases where it exposes some bugs in the parsing. Okay, so one final other thing that I would just want to mention, and this is not core to this presentation. I just want to create awareness of it. For those at the back, there's an underscore before no longer. This is an unusual one. At least I find it very strange, and it's just a source compatibility issue. Existing code that's using the underscore as an identifier will continue to work. It's just it won't compile in 9. If you're compiling your code with 8 and you're using an underscore, you will be getting a warning, and that warning just translates to an error in 9. So I just wanted to create an awareness of that when you're thinking about moving from 8 to 9. Okay, so one of my final slides. What can you do to prepare for 9? So the most important thing and the most disruptive change is encapsulation of the internal APIs. So we've got the JDEPS tool, so I would actually encourage people to run with that and at least be aware if your own libraries or libraries you're using are using internal APIs, because there may be some issues there. If you're moving to 9, you may have to go and they haven't upgraded, or to remove those dependencies, you may have to be forced to run with a command line option to work around it. Version string, just if you know that you've got some code that is looking at java.version and parsing it, just check that out to see how it'll work with the new versioning scheme. The underscore, check for that. I don't know if there's people here that work on tools or compilers that might have dependencies on the runtime image. That is something you can try out now with the JDK9 builds. As I said, that's a disruptive change. It requires writing new code to use the supported API to access the image. So it's just to be aware of that. And I would encourage people to try out the JDK9 builds. So it's a little bit confusing, but we have 2 trains of JDK9 builds. We have the mainline JDK9 builds, and we have the Jigsaw builds, which are the JDK9 builds plus the module system. So the module system is not in JDK9 yet. Not clear when. We'll have to see how the JSR progresses and feedback from from people trying out the early access builds. So two different downloads. I have the URLs to those in one of the last slides. So, okay, other sessions. I listed these at the beginning. And so we've got the intro, the advanced, and the under the hood in this room today at 12:30, 2:30, and 5:30. We have the hack session here tomorrow. It would be very, very useful. I don't know whether the Wi-Fi could cope with everyone trying to download Jigsaw builds. So download it today or from your hotel or whatever, or at home this evening, so that you're not overloading the Wi-Fi in the morning, just to say have it on your laptops to try it out. And Paul Sandus is giving a talk about the SunMISC unsafe situation tomorrow at 5:30. It has it down on the schedule, Hilton, Continental 123. I don't know whether that's one big room or haven't figured out which room yet, so it's around the corner there. Okay, more information. So, they came up in blue. Right, so these are just the URL to where the Jigsaw page is, the mailing list. where you get the early access builds, both the JDK9 builds and the Jigsaw builds. If this is unreadable, just Google for them. You'll find it very quickly. This link here is important, the JDEPS link. This has a page on how to use JDEPS and also has a big table of usages of internal APIs and possible replacements and what plans are for replacing some of those. So that's actually quite useful. Because I brought up the versioning scheme, there's also a link to the JEP 223. And I think that is it. So let's see. So if you've got questions, I think the best thing is to come up here. There's no microphone, but I'm not going to hear people if they shout from the back. And because we're being recorded, I have to repeat the question for the recording. So if you have questions, now is a good time. Mark, do you want to come up for the questions? All right, I don't think there's questions. Okay.
So you talked about new mechanisms in 9 for dealing with some of the things that are currently a problem in 8. Is there a strategy for helping libraries move to those without breaking compatibility with Java 8 earlier?
Right. So the question is there a strategy for libraries that want to be able to target JDK 8 as well as 9? I think is that your question, John Holt?
Yeah.
Yeah. Right. Okay. So I did not mention multi-version jars. So multi-version jars is a way to have a library that has JDK 6 specific code or JDK 9 specific code. Does anyone know, Mark, do you happen to know, is there any talk about multi-version jar? I don't recall seeing anything on the... So Google for multi-version jar, and that will actually provide a way to be able to have code in the one jar file that can target multiple versions. Can we get a microphone turned on here?
There we go. We actually renamed them multi-release jars.
Oh.
There is a JEP for them. The term multi-version jar wound up being too confusing.
Can you give any date when support for Java 8 would be terminated? Would it be 2 years after release?
Support from Oracle or support from someone else?
Well, either, but I don't know when Oracle.
Okay, so for the recording, just the question is about when the support for JDK 8 end. I don't know what that. I can't give an answer.
Well,
to that.
no. We do have an idea, but we're just simple engineers. Oracle's policy for ending its free support is well documented on Oracle.com. Offhand, I don't know where it is, and I'm sorry, I don't remember exactly when it is. But it's publicly available information. It's just not something we've memorized. Sorry.
You don't want to get me wrong either.
Well, yeah, I don't want to guess and
Right.
give you wrong information, but I'm sure you can find it.
Okay, thank you.
Ah, great.
You showed in your slides about Java C tool, some linking errors or reflection. If I'm not mistaken, this is included in the compiler API for source code. It used to have JavaDoc. Shouldn't it be an exported module then? Because I remember there's JavaDoc for this.
And what does what does the JavaDoc for this class say? It says right up at the top, this is an unsupported API. So there are some Java C APIs that are supported APIs, but there are some that are not. And I think this is one of the ones that's not. So that's why it's not exported.
Is this presentation available online?
Okay, so the question is this presentation available online? Not yet, but I think it will be.
You mentioned about the rt.jar and tools.jar. You said that there were file system APIs. What are there? Where's the reference for those?
Okay, so the question, I don't know if it picked it up. So the question is about rt.jar and tools.jar going away. What is the file system API to use? Okay, this is all documented in JEP 220. So what it is it's a file system provider that you can it ships as a jar file in the JDK9 image. And then what the tool can do is it can use the file system API, that's Java NIO file system, to open the target runtime as a file system. And that file system, then you can see at the top level, there's modules and packages oriented view of the file system, and you can see all the .class file and all the resources in there.
So that's like an abstracted version?
Yes.
Right.
Do you visualize? Yeah. Do you visualize the JVM as the bunch of modules going forward? And if yes, how the modules will be zipped? Like it will be a jar file, or it will be some other .mod or something like that?
Well, yes. So the question is, do we envisage it as being a bunch of modules? Yes, and we will be showing slides in this room today where we will show the module graph, and we'll talk about the names of some of the modules that are in there. They won't be all jar files. They're in this internal format. That's already been done in the JDK9 build, so no, there won't be any jar files in the JDK download. They're all in this internal format, but everything will be organized by module.
And will I have the option to include a particular module and then leave out the other modules of the JDK? So question is that, okay, well, if I don't use IO package, can I just load only the required module, not the IO modules?
Right, so the specific example around there's a question about granularity here is so the smallest you can go is something we call the base module. In fact, the next set of slides that we'll be doing here will actually generate a runtime image that only has the base module in there. That includes all the core APIs, which include IO. There's no way to remove some of the very, very core APIs because they're used by just about everything in the JDK. Okay, I think we're out of time. So, one more question. Are we still recording? Okay.
This is not related to Jigsaw. In the end, you mentioned that you're removing underscore as the identifier, and
yes.
We've seen this in HBase code. So just curious why the underscore was picked out.
Oh, do you want to deal with that one, Mark? Or maybe we should send you to one of the Lang tools buffs. Yeah, the underscore.
You go to meet the Lang tools team BOF, which I think is tonight. But the short story is, as the language evolves, we strongly suspect that we will want to give underscore a special meaning in Java, just as it has in other languages. Maybe not necessarily exactly the same meaning as it has in Scala, for example. And yes, we are aware that there are some popular libraries that use underscore, which is why we deprecated it in 8 and started issuing compiler warnings then, and in 9 it will actually be an error. So this is part of evolving a platform. Sometimes to make forward progress, we do have to break things. But we always give fair warning.
Okay, I think we're done. Thanks very much for coming along.
You had a full run. They wouldn't let me in. They wouldn't let you in. They wouldn't let me in. Came at about 11:25. I'm always late for things.
I got confused. I was confusing JavaC task with JavaC tool.
Oh, right. Okay. Yes.
Because JavaC task is an exported API.
Right. So the tool one, I think, right at the top.
use JavaScript to listen to it, to choose bad spaces, you know, and if you cheat a little bit, you can do it and make it work outside the routine too. But that's a sad, you know, sad condition. Very nice. Because when you're trying to do something that will work part-time inside IDEs, you know, you have to resort to this kind of thing.
Well, many things can go wrong with that. You got demos on.
You open it
All right, do you want to get a seat? Because we're going to get started. We okay? Okay, we're on. Okay, welcome. This session is called Introduction to Modular Development. It's one of a number of sessions that we're doing in this room. Some of you may have been at the earlier session today on Prepare for JDK 9. That was not dealing with the module system, but it was dealing with some of the implications of the module system. In this session, we're going to introduce the module, introduce some of the concepts. Alex Buckley and I are going to do an advanced session later on after lunch, which directly follows this one. And then later on today at 5:30, and Alex Buckley is going to do an under the hood for the very, very advanced session. These first three are going to be repeated as well. So if you missed the first one, you can catch up on it later on in the week. We then have a hack session in this room tomorrow morning. Just doing some hands-on and take questions for people who actually want to try it out. So this session, as I say, is an introduction session. It's a very, very gentle introduction to modules. Oh, and my name is Alan Bateman. I work on the JDK in Oracle. We've been working on the JDK forever. For the last few years, been mostly focusing on the module system and the modularization of the JDK. So first slide is, what is a module? Now, for this session, we're going to be using pretty dumb module names. In the advanced session this afternoon, we will have more sensible and more real module names. So just bear with me for the first half of this session where we use these dumb module names. So I want to start at the beginning on what is a module. And what is a module? Well, it's basically a self-describing collection of code and data. The important thing from this slide is to know that it has a name. And if you saw Mark's keynote, you would have picked up on this as well. In this example, our module is called ComFoo bar. Not very imaginative. What's in our module? Well, it's a collection of packages. All the code in the module is organized by packages. In this module, I'm just showing the names of 4 types. They're in 2 different packages. ComFoo bar alpha, and then there's an alpha and an alpha factory type in there, and then there's a ComFoo bar beta package with a couple of types in that as well. Some modules will have native code, some modules will have additional resources, configuration files. I'm not going to deal with any of that in the introduction session. We're just going to talk about modules that have code in this session. The module's description is expressed in a source file called modulinfo.java. So in this module system, there is a file called modulinfo.java that is in your source tree and positioned by convention at the top level directory of the source tree. So I had 4 types in my module in the first slide. This is how they might look in my source tree. So there's a .java file that corresponds to each one of those types. The modulinfo.java is at the top. What is in that modulinfo.java? There's the module and the module name, and I haven't said anything about what's in the module yet, so I've just put curlies and we'll expand on that as we go through the slides. So the syntax is module, module name, open curly brackets, and then we'll have something that will describe the module. So the way I'm going to introduce these modules is I'm going to start by talking about dependencies, and we'll move in a moment to talk about, in a few minutes, to talk about encapsulation. So in this module info, there's typically one or more requires clauses that indicates what other modules that you depend on. This is very, very simple. In this example, we've got ComFoo bar. We just think of it as a library, and it has a dependency on another library, ComFoo baz. So we have 2 modules now in our slides so far. If we had multiple requires, then they would be listed down there in there, and we'll introduce a few more modules in a minute that will have more dependencies. Now I'm going to introduce a third module. So we've had confu bar, which is our library, depends on confu baz, another library. Now I'm going to introduce yet another module, confu app. This has a dependency on two modules, confu bar and Java SQL. What is this Java SQL? For now, just think about it as the module in the Java platform that has the JDBC API. It's the one for accessing databases. In our module info for this module, I've got two requires in there because that corresponds to this little part of the module graph that we're seeing on the slide. Now let's expand this a little bit, and I've introduced a module right down at the bottom in this little module graph called java.base. Java.base is where the core of the platform is. This is where you find JavaLang object. Every module depends on JavaBase, whether you like it or not, because every module eventually, if it has code, of course, will somehow extend JavaLang object. So these dotted lines here are just to point out that there is always a dependency on java.base. In this, I've built up my module graph a little bit here, or my dependency graph, by including the three modules that we've introduced in the slide so far. I'm now going to expand this a little bit further and look at the Java SQL module. So the Java SQL module, this might seem strange, but it has a dependency on the Java XML module and the Java logging module. We'll see a little bit about the Java logging module in a few minutes. Why does the SQL module have a dependency on the XML module? That is because there are types in the JDBC API that are XML types. So there is actually an XML SQL type in the JDBC API. So that is why that dependency is there. All of these modules, they of course depend on JavaBase because, as I said, every module depends on JavaBase. So this is our module graph. Now I'm taking a little subset of that module graph. I've just taken just one little part of it that was in the right, and if I go back over on the right here, confu bar to SQL to logging. I'm just going to look at those three modules. And I want to start looking at what code might be in those modules. And we'll just look at those a bit more closely. Okay, so let's look at the Java SQL module for starters. So our Java SQL module has a class in there called driver. I guess most people actually know there's a Java SQL driver. That's one of the most commonly used classes in the JDBC API. It has a public method in there that returns a logger. Okay, so the logger is in this other module down at the bottom. It's in the package Java Util logging. I've now got code in my application module that is invoking that method. So it has a reference to a Java SQL driver and is invoking that method. So let me see how this works. So we're calling the getParent logger, and then I'm going to invoke the log method on the logger that the driver is giving me. Okay, so how do I relate to this in my little dependency graph here? Well, I can't see how that's going to work because I don't have a dependency in my confu app module on the logging module. Maybe I'm forced to introduce that dependency. Do I have to do this? That would be very inconvenient for me because it means that I now need to know the transitive dependencies of any of my modules that I depend on, and if they've got APIs that are exposing other types in other modules, then I've got to know about those. That's not very intuitive and is a little bit error prone, particularly if they'll change over time. So in this module system, there is this notion of implied readability. So if a module depends on another module, it's said to read that module. In this example, what we do is we have a module confu app that depends on or reads Java SQL. Java SQL reads logging, And the way for the SQL module to be a good citizen and let the consumers of its module know that it's returning types in some other, or it's got method signatures that are in some other module, is it declares that dependency in a special way with called requires public. And what this does for the module system is it means that the application module here, ComFoo_app, will read the Java logging module. This is something called implies readability. So the ComFoo_app reads the SQL module because I require it, and it also now will read the Java logging module because the SQL module has essentially re-exported that. So now what we will do is we will add these implied readability edges to our module graph and see where we get to. So the new edges that are added to that graph, so I went from a dependency graph, now I've got my complete readability graph. These new edges that I've added based on this new concept of implied readability are these yellow edges or orange edges in this graph. So there's one additional one that I haven't shown, and that is the ComFoo_app to Java XML. This is also because of implied readability, because as I said a few minutes ago, the Java SQL module has some types in there in its API that are XML types. Okay, so that's how we went from dependencies to readability graph. I now want to actually look at another concept in the module system, which is encapsulation. So in our module info to date, we've just been requiring other modules. This next keyword that I want to talk about is the exports. If I am a library developer, I can essentially partition my module into two. The API packages that I want people to be able to use because they are part of the API that I export. And then I've got my internal types that are in packages that I don't want anybody to use. So in this diagram here, I've taken the ComFoo_bar module. I've divided it into two. I've got my ComFoo_bar alpha and beta packages. That is the API that my library exports. They're over on the left. My internal packages, even though it contains public types, I don't want anyone using them. These are only internal to my module. These are not exported. So in the module declaration, the way this is done is exports, the name of the package that I want to export. So in this module declaration, there are two packages exported. There are some internal packages that are not exported. I'm now going to bring the two concepts that we've talked about together to talk a little bit about accessibility. So we've got our application module and we have our library module. Our application module is ComFoo_app. Our library is ComFoo_bar. Our ComFoo_app module reads because it requires the ComFoo_bar module. And what this means is that it can access the public types in the exported packages of ComFoo_bar. It cannot access anything that is in the non-exported packages. So this big red X on the right here is, these are my internal packages. Even though this module, ComFoo_app, reads my module, it cannot access any of the types in that module, even if they're public. And just to enforce that is, let us suppose that read edge is removed. ComFoo_app does not read ComFoo_bar. That means that no types within that module are accessible. If I go back and reintroduce the read edge, they're accessible again. So the important things to understand about accessible is a type is accessible if it's in a module that you read and it's also a public type in an exported package. You have to have both together in order for a type to be accessible. The main thing to take away from this is the notion of public changes with the module system. Alex has, for the Under the Hood presentation for later on this afternoon, will go into a lot of detail to explain essentially the different types of public. But this is a huge, big change to the platform because there is code out there that will assume that if a type is public, it must be accessible. The module system changes that. So that's the one thing to take away from this part of the presentation around the concepts. Now I want to switch gears a little bit and just talk a little bit about moving on from concept, showing you some of the command lines as to how you compile modules. I want to talk about running modules, and I also want to come back to the Java SQL module and the Java logging module that we had there to explain what they are, because they are platform modules. Anyone that has come to JavaOne over the last couple of years will have seen spaghetti diagrams. This is a cleaned up version of our module graph, where we have, over time, cleaned up the JDK so that we can have both standard and JDK modules. This is a nice, this may look complicated, but it is significantly cleaner from where we were a couple of years ago. There's no cycles in this graph. There's clean dependencies. We can build, and the JDK, a module at a time. It's taken us a long time to get there, but this is what we have at the moment in JDK9 and in the Jigsaw builds. For those that have tried the Jigsaw builds, you will actually be able to run the list mods command and see the complete list of modules that are in the JDK. The modules that start with java.something are standard modules. They're Java SE. In the examples that we've had to date, I've talked about Java base. We'll probably see that in that list. It's third or fourth one down, or third one down there on the list. If you search, you'll be able to find the Java SQL, the Java XML, the Java logging modules. We've been able to divide the JDK and the standard APIs into these set of modules. There are also modules that are named JDK.something in this list here. These are JDK-specific APIs. They're not Java SE standard APIs. Some of these modules are tools. Some of these modules are service providers. They don't export any API. Some of these modules export JDK-specific APIs. In the presentation this morning where we talked about internal APIs, I introduced the idea about java.star being standard and then sun.star being internal. There's in the middle, there's a bunch of APIs that are com, sun, something, and there's endless confusion as to whether they're supported APIs or not. The module system fixes all of that by having it clear that only the supported APIs will be exported by these modules. So if you try out the Jigsaw builds, you'll be able to see the full list of modules. So I want to move on now and just show some of the command lines we'll first start compiling some modules, and then we'll start running and see how it comes together. Okay, back to the example that we had in one of the first slides. I'm going to compile here one of the leaf modules, which was the com.sun.baz module. And this is the javac command to compile this. Javac takes my Java source, compiles it, and outputs a corresponding tree of .class files. And this is exactly what happens when you're compiling a module. The module info.java gets compiled to a module info.class in the build, output, whatever directory you want to call it. In this javac command, the -d here, if you're familiar with the javac command line, then that's what the output directory is. And by convention, we're using the module name as the directory for both the source and the output/destination directory. So this is one javac command to compile one module. Before I move on and explain some other javac commands, I need to introduce something called a module path. This is the module equivalent of a class path, if you like. There's in the module system and in the Jigsaw builds, there is a new command line option called module path. There's a shortened form version of it, MP. So we've got class path with a CP. The value of the module path is essentially a sequence of directories where to find modules. When I want to compile a module or I want to run a module, and where does com.foo bar? And I have to go and I will be able to search through the module path to find it. Later on in the presentation, I'll talk about packaging and some other details, but just assume it's a sequential search through first directory Does that module exist? No, it doesn't. Second directory, does it exist? No, it doesn't. Third directory, oh, it exists. That is where the module will be found. So it's a familiar concept of how do you find modules for those that are familiar with the class path. There's a number of significant differences between this and the class path in that you cannot have multiple modules of the same name in the same directory. So if I put two versions of some module in dir 1, module system said, no, can't do that, can't figure out which one you want. So it avoids those kind of errors. So now that we know what a module path is, we will introduce it into the javac command that we had, and we will compile one of the other modules. So remember in our little module graph that we had confu bar depends on confu baz. How am I going to compile confu bar? Because it has a dependency on this other library, confu baz. So the way this works is I'm going to exactly the same javac command, but I give it the module path so that it can look in that module path to find the modules that I depend on. And exactly the same as the previous example, we go from .java to .class. Same convention as previous is the directory names on both the source and the output is the module name. Now I'm going to move on. I've got my modules compiled. Let me see how I'm going to run them. Okay, here we have a new command line option, -m, to give it the main module or initial module. This looks a little bit complicated. We'll simplify this as we go through some of the other slides. For now, just bear with me. javac has a module path option. Java Launcher has a module path option. The main application module is confu app. The main class in that module is confu app main. -m, I want to run this module, and this is the entry point or the main class in that module. And that's what this syntax module / main class is. As I said, we'll make this simpler in a few minutes. I want to show what happens now when we run this. My initial module or my main module is confu app. It has a dependency on confu bar, on Java SQL, and of course Java base, because everything depends on Java base. So what happens is it locates module confu app. It looks at its module descriptor, figures out what it depends on. Then it has to compute the transitive closure to get the full set of modules that are in this module graph. So it's essentially generating this module graph when I run the java-m. So I go from here to here, and this is my module graph again that we had earlier on in the presentation. This is all computed at startup when I run the main application. So the important things from that is because it's located all of the dependencies, transitive dependencies, we know that there's nothing missing. When we go to the advanced talk or we go to do under hood, we can actually prove a whole bunch of other correctness issues around this module graph. I'm not going to get into it in this presentation. But we can ensure that we're actually starting up with what we call a reliable configuration. If you're interested to see what really happens at startup and see more of the detail, there's a diagnostic option. So if we're playing around with the jigsaw builds at the hack session tomorrow morning, this might be one of the things we might actually try, is run it with this xdiag resolver option, which is essentially a diagnostic option to get us to do print out some traces during startup, so you can actually see where it locates the modules and what depends on what, and you see a whole bunch of other details. The output that you see from that tracing option is essentially how it's actually building up this little graph that we had on the previous slide. Okay, everything that we've done so far has been very basic command line, compile, got my output directory, everything is exploded on the file system. I want to spend a few minutes just talking about packaging my modules, because it's packaging is important because I don't want to be shipping down a big tree of class files around the place. Okay, jar files. We're all familiar with jar files, I hope. We can package up a module as a jar file. We call it a modular jar. A modular jar is just like a regular library, except it has a module info.class in there. That is the compiled form of the module info.java. I've got a command here. This is an updated version of the jar tool. So the jar tool has been upgraded very significantly in the Jigsaw builds to support a whole bunch of new options related to modular jars. So I'm creating my jar file with this command. So there's a -- create, which you may be familiar with jar C. This is exactly the same thing. Give it the name of the archive. In this case, I'm going to package up the application module into app.jar. I'm going to use this option to indicate what the main class is. So as part of packaging, I can add other information and other metadata to the module. And one of the things I can add to the module when I package it up is indicate what its entry point is. So in this example, the entry point is comfoo app main. So I'm going to indicate that when I'm creating the jar file, and then I package it up, and I've now got a modular jar. Let's look at a modular jar. So there is a print module descriptor, or the shortened version of that is -p, where I can look at the jar file and I can understand what its dependencies are. I can understand what it exports. Because for this example, I've packaged up the main application. It doesn't actually export anything. It's the libraries that it depends on export, some API packages. But for a main application, I can see what its main class. And there's other things in a more advanced example we might see being printed out from this. So this is really useful because if I've got a jar file that's packaged as a module, I can see exactly what it depends, exactly what API that it provides. Now we will go back to our java-m and see how this looks. Our command line has now shortened. A few minutes ago, we had to go and we had to specify to the Java launcher what the initial module is, what the main class is. Because the initial module knows what its main class is, I don't need to specify that. So this gives me a shortened command line, which is nice. So with our modular jars have another wonderful property in that it gives us a story for how you can have a library that works in 8, that works on the class path with 8, but works as a module in 9. That is an important thing to understand about a modular jar file. The module info, remember it's module -info, isn't a valid Java identifier. It's not going to be recognized as a class file by older versions of the platform. It'll be just ignored. So what this means is that I can exploit that to be able to have a library that works in 8 and 9. It can either work on the class path or it can work on the module path. So this is all part of the migration story. And we'll be talking a lot more about migration in the advanced talk later on. So I'm going to come back to one of my libraries, which is the Baz library. It's packaged as a modular jar, but I'm going to use it on the class path, and it just works. Now, there's an assumption here that I've compiled that library target 8. I haven't, or -release 8 if you're using the newer version of Java C. Of course, if I compile it for 9 and I put it on the class path of a JDK8 installation, then it's going to complain that the class file version, or it will eventually complain the class file version has been revved and it doesn't recognize it. But assuming I've compiled it for 8, then I can use it as a regular jar file on the class path. Now I'm going to take that same jar file and I'm going to put it on the module path in 9. So all of my libraries now are on the module path in this example. So my Baz is being loaded as a library here, as is the main application and the other libraries. One other thing we can do, and this requires a little bit of a deep breath, but we can actually mix the class path and the module path. And this is also important for migration, because over time you would like to see that the common libraries will get migrated to modules, but the rest of the system hasn't been migrated to modules. So I can continue to have the rest of the system on the class path as before, but anything that has been migrated to modules, I can have that on the module path. Now, this requires a little bit of thought because I'm not giving it an initial module. Remember when in the previous slides where I showed the module graph and what happens at startup? There isn't an initial module to think about here. There could be 1,000 libraries, modular jars sitting in that mlib directory. How do I know which ones that I'm supposed to load? And this is the reason this example has an add mods option. I need to tell it that I want to make use of this module conf-foo-baz. There's nothing in my code on the class path that tells me what my dependencies are. Therefore, I'm mixing the class path and the module world, so the -add mods is telling me what these modules that need to be resolved. And conf-foo-baz, if it's got all these other dependencies, they will get resolved then as part of this initial startup process that I talked about. Okay, so that is a little bit of introduction to some of the possible migrations. I next want to spend a little bit of time just talking about linking. So for those that were here at the Prepare for JDK9 talk this morning, I talked a bit about JEP 220 and the modular runtime image. I mentioned a teaser in that the possibility that we could actually take an application, a bunch of libraries, and create a custom runtime image that contains only the parts of the JDK that application needs. And I can do that through this process of linking. The linking and a linker is something that has never really existed in the Java ecosystem. We've always had compile to classes and we run. There may be some packaging in there, of course. There has never been a link step in there. What the module system brings along is an optional link step where we can actually link a bunch of modules together and the current linker will, in the current builds, will generate a custom runtime image with just the modules and their transitive dependencies that you need. So, I didn't move on and just show what it actually looks like. So, I have more slides on this in the previous talk, but essentially just think about it as I've got a set of modules, the transitive dependencies. I'm going to produce a modular runtime image. Modular runtime image, think of it as like a JRE, but it's a modular JRE. It has a bin directory for launchers. It has a conf directory for user editable configuration. Ignore everything else in it because it's implementation specific. And this is the way the JDK9 builds are actually been shipping for the last almost a year now. We've moved to this modular runtime image, got rid of the rt.jar, tools.jar. Everything is in a much more efficient representation in the runtime image. And this is the modular image. And the modular image is not limited to the JRE or JDK. It can be any set of modules. Okay, I hope this is readable at the back. This is a JLink command to create a runtime image that has one and only one module, java.base. Java.base is the core of the system. It does not depend on any other modules. What I'm doing here is I'm running the JLink command. That's the JLink is the linker. It has an option to give it the module path. What's that for? It's to where to find the modules. There's an add mods, just like Java add mods, which is what modules to add to this when we're creating this image. And I'm giving it an output directory as to where to create the image. This is the most basic JLink command that we have, and will create a runtime image. And when I run the Java list mods, you might remember in one of the early slides, I did a Java list mods on the full JDK, and I had a screen full of java.star and jdk.star modules. This one runtime image that I have here contains only one module. In an embedded system, this might give me a runtime image that's only 10 or 12 megabytes, and that's really nice. Now let's move on to our JLink command. And I'm going to create a runtime image with my Confu app module. Now my Confu app module, remember our little module graph, it depends on Confu bar, which depends on Confu baz, and depends on Java SQL and XML and logging. We will create a runtime image with that, this module. All of its transitive dependencies will be linked in, and we get a small runtime image that only has 8 modules in it. That's really, really nice. So what we see from this is that I have created a runtime image that has Java modules, standard modules, and also some of my own libraries, and also my own application, and they have been linked in together. Okay, I've run ahead of myself, and this is where I've ended up on the. We have more slides in here on testing that we thought were a little bit too advanced, so we moved them to. We talk about them maybe at the hack session tomorrow. But the main thing to take from this session, I realize it was shorter than you might have expected, is just really wanted to introduce you to some of the basic concepts. So we've talked about modules. A module has a name. It declares its dependencies. It declares its exports, and also introduce you to some of the basic commands that we have with Javac and Java, and the fact that they're being modified to support support modules. So we're back in here again at 2:30. Alex Buckley and myself are doing the advanced session. This one is primarily focused on migration. We'll get into a lot more detail on how to move libraries to modules. Alex is back here then again at 5:30, again this room, to do an under the hood, which is a more advanced session. And then we're back in here tomorrow morning for some hands-on, for those people who actually want to try out Jigsaw. We'll take questions. More information. So 2 links. Project Jigsaw page in OpenJDK has a link to all of the JEPs and all of the other material and documents that we have. There's the mailing list, Jigsaw dev list. There's also a link there to the early access bills. You can just Google for them if you can't read it from the back. And that is early access bills. So that's it. So Mark, do you want to come up so Mark Reinhold is supposed to be talking today as well, so he's going to come up and help answer questions if there's questions. Okay, there's no microphone, so what we did in the earlier session is either repeated or come up and read into the microphone or shout into the microphone.
I was going to ask, is the public not accessible thing at only the runtime or also on the compile time?
Okay, so the question is if something is not accessible, is it both non-accessible at runtime or also at compile time? The answer is both, yes. I should have made that clear during the talk, yes. So you will actually get a compilation failure if you actually you've got some reference to some type that's in a non-exported packages, your code won't compile. So and then if you do compile it to some ways, then it'll fail at runtime.
And that comes into effect only when you create the module class, right? So until you create the module class, public still gets compiled.
Okay, I didn't quite catch. Did you say clear?
You have to create the module class, which actually defines the
Correct.
imports and exports.
Yes.
Until you create that, it's still accessible, right?
Yeah, if it's exported and it's public and you have a dependency on that module, then your code will compile and run.
Okay.
So there is no more runtime.
Speak into the mic, please. We're on a video stream.
Okay.
So there is no more runtime and compile time dependencies. Everything is both.
That is okay. So for the recording is the question again was whether these module boundaries apply to both compile time and runtime, and the answer is yes.
And does this make OSGI like redundant maybe, or I mean this seems very similar to OSGI concepts where you export and import the packages.
Cool. Could we get the mic, the podium mic? Thanks.
Thank you. There are some similarities, but this is quite a different module system than OSGI. OSGI does a whole bunch of other stuff that maybe you need, but often you don't. And OSJI doesn't do some of the things that we need for modularizing the platform itself. So that's why it's different.
Thank you.
So is there any solution for optional dependencies?
Yes, the solution for optional dependencies is services. Yeah, in earlier prototypes of Jigsaw, there was a notion of optional dependencies, but we found out that working out the semantics of them got really, really hard. And I think Alex ultimately convinced us that this is just a bad idea. And at least our experience in the JDK and some other code bases we've looked at is when something's optional, it's often very straightforward to refactor it as a service. And in fact, modules, things we haven't shown today are, modules can also declare that they provide services, that they require services, and that's all hooked up with the existing service loader API. So if you need some optionality like that, services are generally the way to go.
Hi, two small questions about JLink. First, it creates a build that is specific to the platform in which you ran JLink.
Yes.
If you run it on Linux, you'll get a Linux build. Yep. No option to, if you run it on Linux, auto-generate a Mac build or something like that.
Oh, okay. So there is you can build it for other target platforms. The most obvious is when you're doing cross compilation to Linux ARM or something like that. You're not going to run the tool on the embedded system. You'll run it on some host system. So
okay.
yes.
And is there a way to, for instance, in JLink itself, specify the main class to run? So that you don't have to run that specific Java binary and then specify the main class. Basically solve the problem of self-executing Java.
Right, so in the current version, it does actually generate a very basic launcher. That is the name of the application. There's more work will be needed, I think, to make this a bit more smarter and integrate properly with the native toolchain. But it does actually generate a wrapper at the moment around Java for the application. Anything that has a main class.
JLink is the foundation for other tools as well. For example, the Java packager that was originally started out as the Java FX packager is being enhanced they're rebasing that on top of JLink. So some of the additional stuff that you need to do in order to build a shippable Mac app that you can put in the Mac App Store will be done by Java Packager. It'll use JLink to get most of what it needs and then do the additional, really Mac OS specific stuff for that.
So there will be a JEP on JLink soon. It's in the Jigsaw builds, but there isn't a big detailed JEP. We'll have to add that soon. So that'll detail all of its capabilities and options.
Thank you.
Will you be able to version modules? Or?
Versioning is a fun story and a common topic. Do you want to answer this? Get Alex to answer.
I have a very simple attitude to versions. If I see them coming down the street, I go to the other side of the street.
Yeah. So in the proposal, the initial view we've taken on versions, and this is after again experience with prototypes where we had very deep support for versions, is versions are, from the perspective of a module system embedded in the VM and the language, versions are almost extracurricular, right? They're useful information. We have a way to embed a version string in a module when you package it. We have a way to query it. You can get the version string out. You can compare them just so there's at least one way to order them and compare them. But the view we've taken, at least for now, is that versioning is this fantastically hard problem that other tools like Maven and Ivy and Gradle have solved, maybe not great, but well enough, and we don't see a need to replicate that kind of solution or try to do an even more perfect solution involving a SAT solver or something really high tech inside both the compiler and the VM. That seems like massive overkill. So the general model here is, we're not trying to go out and replace the existing ecosystem tool chains. We're not trying to replace Maven or Ivy or Gradle. We're trying to provide a foundation upon which they can build. So it will still be up to your build tool to help you select versions, deal with version conflicts, and so on and so forth, and make sure you get all the right modular jars on your module path. Once they're there, then the module system at both compile time and runtime will do the right thing. It'll be able to report version strings as documentation and in exception messages and so forth. But it will not try to do something clever when it comes up to a conflict. It'll just say, oh, no, you have a conflict, go fix your POM or whatever you need to fix to make it work right. Now, is this the absolutely correct view? Maybe not. But when we realized that this was a potential way to simplify what we're doing, we found it incredibly attractive.
Hi. I'm a performance engineer, so my perspective is warped. At any time at the Java...
Worse than that, you're a GC engineer.
At the Java C level or the JLink level, can you do cross-module optimizations, like inlining or constant propagation or anything fun like that?
Absolutely.
Yes.
That is one of the longer-term plans for JLink is one of the really attractive things is the ability to do whole program analysis. You've got all the modules, both modules from the JDK, from your application, from libraries you got from Maven Central, whatever. JLink can look at them all at once. In fact, JLink already has a basic plugin architecture. So you can plug in things that will do filtering, like throwing out debug symbols or doing some basic optimizations. So that's part of the long term.
Follow-on question is, do you allow dynamic class loading, and does it ever invalidate any of those optimizations? Dynamic, if somebody cons together a class path to something that wasn't in the modules, does it just throw an error, or?
Oh no, the class path is still fully supported. If you have an application that spins up custom class loaders, URL class loaders, something else, that'll still work. The class path is still there. If you come to the next session in this room, you will learn, or is it the next session or under the hood?
It's
the next
for
one. Sorry. Sorry, is it advanced or under the hood? That's right. In under the hood, Alex will explain how we deal with the class path. So the class path is treated actually as a very special, an instance of a very special kind of module. It's an unnamed module, kind of like the unnamed package.
But what if that invalidates some of those optimizations you did in JLink?
Oh, it won't invalidate them because we will be able to detect for conflicts.
Hi, your example was good, but it is only particular to one module. What about third-party systems? We use a lot of third-party libraries, right? They may not have migrated to module or something.
Come to the advanced session.
Right. We deal exactly with this discussion in the advanced talk at 2:30.
Yeah, we've thought about this a lot. We have a
2:30 here in this room. Oh, sorry for the recording. Maybe it wasn't picked up. The question was, what about all these third-party libraries? How can you make those modules?
And the short answer is, in many cases, you don't have to right away.
So how does the module system change JNI bootstrapping?
How does the module system change JNI bootstrapping?
Okay, so startup is very different, but if you're using, if you mean JNI bootstrapping, I presume you mean the JNI invocation API? Yes. It works exactly the same as before. Okay. And if you've got your own native launcher, then it can pass in these options to specify module path, and it just works.
How do the new visibility rules interact with introspection?
There are no new visibility rules.
Well, okay.
Visibility.
Yes.
Come to under the hood.
Right.
Question. Suppose I want to have access to a class in a package that is not exported from the module. Is there anything I can do to override this restriction?
Is there anything you can do to override the restriction when a package is not exported? Yes, you can use a command line flag to break encapsulation.
Yes, we used this, by the way, in the Prepare for JDK 9 talk this morning. So you might get the recording of that or get the repeat later in the week.
So if like A requires B and B requires C, so then when you define A, do you have to say any C, or it can be like a lookup by B?
It'll be looked up. That's all. Transitive closure for the win.
Yes.
Thank you.
out of curiosity, how does the public non-accessible classes work for JavaDoc? Is that still going to be made?
Sorry.
For generating JavaDoc, is that going to be described the same way as?
So we are upgrading JavaDoc so that it understands what modules are and displays, displays modules along with packages and classes and everything else. And if a class is in a package that's not exported, then by default JavaDoc will not generate any documentation for it.
Okay, I think I'm kind of glad I finished early because
one more taker.
Later. Okay. Okay, I think we're done. Thank you.
All right, thanks.
Check 1, 2, 3, 4. Hey, 1, 2. Microphone check 1, 2. I'll probably check. Sure, mic check 1, 2, 3, 4. Hey, 1, 2. Check 1, 2, 3, 4. Check 1, 2. Check 1, 2, 3, 4. Hey, 1, 2. Check 1, 2, 3, 4. Hey, 1, 2. Check 1, 2, 3, 4. Hey, 1, 2. Yep. Better? Yeah. Check 1, 2. Microphone check 1, 2, 3, 4. Hey, 1, 2. Good?
So you want to do like this, or what did you guys please? Just so you could stand and have like a platform?
Yep.
Okay, right on.
Thank you. Yeah. In all of the talks that Brian's ever given with the laptop here, I've never seen one where it falls off. I'm the first half, Alan's the second half. So yes, yes is the answer. Yeah. Okay. Okay, I will stand here. Forget at 2:30. A lot of confusion. I guess you have to clear it as well. Thank you. Yes. Now it is. Yeah, this is the same laptop from earlier.
There's quite a line there. Oh,
Oh my gosh. It's a layer. Oh my gosh.
HDMI. Just need to see actually where do I fit in on this presentation? We're not connected, so let me just do a little quickly check.
Somebody's phone is ringing.
Library migration. I'll turn off someone's phone. Yeah.
It's not mine.
I run from the Jacksonville. This is my graph.
It's an iPhone ringing.
Right, okay.
Maybe the projector is online.
Okay.
That's an iPhone ring.
Yeah, I'm just getting this set up here.
Yep. And you'd prefer to use the lavalier again?
Excuse me?
You'd prefer to use the lavalier again as opposed to the podium mic?
Alex, which one? Alex, I think Alex.
I don't care which laptop.
No, it's the mic.
Oh, I'm going to stand here.
You're going to stand here.
I'll use it.
I'll tell you what. Alex will use this one, so I can use the I can use that one. So I'll be taking over about halfway through. Yeah, if we could take this down, that would be good, because it's just a huge amount of tension in this. It keeps popping out. This is the HDMI one. Yeah. Yeah, if we take that down, this is my one, I think.
You're still doing your introduction, right?
Yeah.
Okay. Did you see my mail?
About versions?
Yeah.
No, I can do the podium mic as well. We need that. We need to use the podium.
You think I should talk about it in the intro?
We, by the way, we
That
still have
says
this
Alan
slide.
on it. It's not yours.
Huh?
Pretty sure it is.
Sorry?
I suppose. Do they normally give half caps? This is
a latte.
Right.
That was a venti hot chocolate.
They shortchanged you significantly.
Why? Because it's not full. File a complaint.
Okay, so if we could
Thank
keep
you,
it down.
Oracle, for
Perfect. Yep. Great. Okay, now we got it. So
Only, I mean, given the number of... Yeah, we're on. I wasn't expecting so many questions, so much enthusiasm, actually, from questions in the previous two talks. So it's come up already.
Well, yeah, of course. I mean, it came up on Twitter yesterday.
Yeah.
It came up walking out of a
Yes,
hall yesterday.
it came up whilst you were still giving the keynote, and Moser.
Oh, yes, he was there.
Yeah.
You know, so given that you're doing an introduction, and given that we know we're going to get questions about it, why not make a statement? But it's not, you know, it's not just there are no versions. There are versions, just they're not exposed in the language. I guess I haven't sent it to you. So I've added 2 slides on, okay, what can you do with layers? And I show different versions of Guava and Jackson in different layers that don't interact. And say, look, there's no problem setting this up at all. It's carefully done, so it's not just class loaders, you need a layer as well.
So I just
Oh, yes.
set up here. So
Okay.
the slide was showing. Next slide, you're announcing.
This is government.
Oh yes.
Yeah. So yeah, in Bruno's clear, so there's always a feature that everyone just assumes is obviously going to happen. And it's not wrong to assume it's going to happen, but the feature itself is more trouble than it's worth. And the Lambda example went down quite well. Everyone assumed you could mutate the sum variables, and then that desire just evaporated once people saw streams. Evaporated, but That was why Nexus 5 was so good. It was just so well sized, and that's why people thought the 5X would just be this perfect blend. It's too much.
See what we have at the end of this one. Okay, we want to shorten time. I can skip through the limited section at the end because we cover that with English, so we can actually I can bring it to here. Well, that's your module six. Starting at the bottom, having your modules on top.
Ah, yes, and the graph that I sort of wanted but can't quite get to.
You can't quite get to this. No, you've got the messy graph.
Yeah.
Yes.
Unless they put lots of whipped cream in.
Oh, that was the question. Was there cream?
I didn't know if you wanted cream or not. Oh, so they should normally fill it up a little more. Times a doubling, 925.
If you want to. If you want to start.
This is not a finished. The reason we're here is to explain it as best we can.
Yes. Show you back.
And I can do the second thing and hand it to Alex. Okay. What's after the second slide? Alex is first.
Yes, Alex is first.
Yeah, application creation.
Well, there's actually a slide for Mark in there. Should I remove that one?
Oh, that requires not writing.
Yes. I left that in.
Yeah,
Okay.
If Mark's not available, what would we do then?
There you go. Now you're on. It'd be interesting to see what your reaction would have been.
Donald Trump, you're fired. Good afternoon, and welcome to Advanced Modular Development. So this is part 3 of a series of sessions. We're doing the first 4 today. 2 of them we already did. This is Advanced. Jigsaw Under the Hood, Alex will present in this room at 5:30. And then the Project Jigsaw Hack session is bright and early tomorrow morning in this room at 8:30. So if you have questions that we don't have the time to answer today, or you want help hacking on your code or whatever, please come tomorrow morning. So let's go back. I'm Mark Reinhold. This is Alan Bateman, Alex Buckley. There's a seat down here in the front if anybody wants it. I'll just make a couple of quick remarks before Alex digs in. An important thing I really want people to understand is that this is not finished work. You know, a big part of the reason we're spending so much time explaining this system today is that it's a proposal, it's a prototype, it's a fairly complete prototype. It's a design that still has some rough edges and some missing parts, but we are at a stage where we really need feedback. We want to get this right. We do not want to do something in Java 9 that turns out to be the wrong thing. As James Gosling has said, I'd rather do nothing than do the wrong thing. So we really value your questions and feedback. So don't be shy. All right, Alex.
Hi, everyone. I'll just wait a minute for some people to sit down. Okay. No one standing, no one sitting in the sides. Good. So, I'm going to talk for about half of the presentation about application migration, and then Alan's going to talk about library migration. And the theme that you should detect is that advanced modular development in some sense is, because there's so much Java code already out there, mostly about migration. So at heart, a typical application has 3 layers. At the top are your jar files. At the bottom is the JDK, and in the middle of this sandwich, in some sense, is the filling. A bunch of jars downloaded from the internet and thrown on the class path. And we've drawn it as a cloud because clouds are cool. There's just this big mess of stuff. In Project Jigsaw, we've turned the JDK into modules such as Java Base, Java Logging, Java SQL, and Java XML. The benefits of modules, you've probably already heard, are strong encapsulation, so that no one outside a module can access its internals, and reliable dependencies, so modules know what they need, and there's no need for you to set the class path. If this sounds good, you might be wondering how to turn your application into modules. Let's put some names on these jars to get started. Let's assume the main application is myapp.jar up there at the top, and it has some helper code in mylib.jar. And let's assume that the cloud of third-party jars can be simplified to just Jackson, the JSON processing library. Jackson comes as 3 jars: core, data bind, and annotations. If you can read the slides from the back, you might see that the current version of Jackson Core and Jackson Data Bind is 2.6.3, but for Jackson Annotations, it's 2.60. Versions are hard. We don't know why that is. Ask them. Of course, to run the application today, you have to ensure that the class path is set up like this. I've got myapp and myapp jar and mylib.jar in the lib directory, along with the Jackson jar files, and you have to set the class path up just so correctly every time, and the runtime has to search all of it, and then there's myapp.main, the main class, at the bottom. You wouldn't have to bother with that if myapp.jar and mylib.jar turned into modules. Now, turning each jar into a module one-to-one is a fairly natural way to proceed, so I'm going to go with that theme for now. It's not always possible, especially if jars have cyclic dependencies among their classes, but let's go with it. Each jar becomes a module. Now, whenever you see a module, you should ask two questions. What does it require, and what does it export? Let's ask that for each of our prospective modules that I'm calling myapp and mylib. One way to find out what a module might require is to run JDEPs on a jar file. JDEPs is a tool in JDK8 that analyzes classes in jar files and finds whatever classes they refer to in other jar files. Here are the results of running JDEPs on myapp.jar and mylib.jar. The classes in myapp.jar make use of classes, this shouldn't come as a surprise, right? Make use of classes in jacksoncore.jar and jacksondatabind.jar, and also, of course, in mylib.jar. That's where the helper code lives in your application. Plus, of course, myapp.jar uses classes from the Java base module, like object, right? And also Java SQL. That's just the example. And, of course, oops. Mylib.jar also refers to classes in Java base because that's where object is. With that knowledge, we can start to write the module declarations. Here's the module.info.java file that declares the mylib module. All it requires is Java base. It was that last line on the previous slide. Now, JDEPs can't realistically help you with exports. There's a bunch of packages in a jar. How does a JDEPs tool know which of those packages are meant to be internal to a module versus exported from a module? It can't know. So for the sake of argument, let's say that the mylib module exports a package, com myapp.libutil, and it exports it in particular to the myapp module that we're going to make. That's a qualified export because it's specific about which other modules can access the package. Let's turn to the module.info.java file that declares the myapp module. It requires mylib, the module we created on the previous slide, and Java base and Java SQL. No surprise. And of course, we know it's going to use Jackson. So we'd like to write requires Jackson core and requires Jackson databind. Does that mean we would have to write module.info.java files for those Jackson jars? That would be a pain. What we really want is some way for the Jackson jar files to somehow become modules automatically. Then we could write the module.info Java file for myapp like this. You'd require mylib, a module that you wrote yourself. You'd require Java base and Java SQL, modules that we wrote. And you'd require Jackson core and Jackson databind that the cloud wrote. We would have a beautiful module graph. See how green it is, right? With myapp depending on mylib, and on Jackson core and Jackson databind, and also on Java base and Java SQL. Beautiful. We can do this. The solution is automatic modules. An automatic module is a jar file that you put on the module path rather than the class path. Once you do that, you have a real module. That is, there are no changes to someone else's jar file. You don't unzip it and change the manifest and rezip it. The module name is derived from the jar file name in an obvious way. The automatic module exports all its packages, because you don't write anything to say what should be exported and not. And the automatic module requires all other modules on the system out of the box for free, as if by magic. Now, can I make the notes a little bigger? I have to make the notes a little smaller.
You can scroll them down.
Okay.
Scroll them.
Okay.
We refer to this as the messy slide.
This is a messy slide for many reasons. So, once automatic modules spring into existence for Jackson Core, Jackson Databind, and Jackson Annotations, the module graph you can see looks quite different. The automatic modules, highlighted in red, basically require everything. Let's be clear, they require each other automatically. They require all modules in the JDK image, so each of those three modules is pointing to each of the Java modules. And for reasons that will become clear when Alan covers library migration, the three automatic modules also require your MyApp and MyLib modules that you declared explicitly. This is to provide the maximum possible compatibility surface for code in jar files. You might think that the module system could run JDEPs on the automatic modules at startup and try to figure out what modules they require. But that doesn't really help for two reasons. The first reason is that the libraries that you find in the filling of the sandwich often make use of core reflection, that is the Java-lang reflect API. And they do that to load classes dynamically, such as from your code. JDEPs can see the use of core reflection, but it can't see what classes are loaded by core reflection because it's dynamic. The second reason we don't run JDEPs to figure this out automatically is that automatic modules are actually more powerful than modules that you declare in moduleinfo.java. The reason they're more powerful is because automatic modules can access types on the class path. Now, we don't want to scan the class path at startup trying to figure out which jars might be accessed by which automatic modules. The class path to the module system is really a black box. So we simplify matters by saying, it's a mess, we're proud of it. The automatic modules basically read absolutely everything they possibly can, including code on the class path, to maximize compatibility. It's not that bad, actually, in some sense. It's better than when everything was a jar in the class path. For example, there is no arrow from MyLib to MyApp, or for that matter, from MyLib down to the three automatic modules. So there's no danger of code in MyLib accidentally reaching out and touching code it shouldn't. Contrast that with on the class path, code in mylib.jar could access code in myapp.jar because they're both on the class path, and that's the kind of thing that causes maintenance headaches down the road. In fact, if you think about it, the class path is crazy. With just 10 jars, you get 100 possible ways for code to interact, because code in any jar can refer to a type, and the VM will go through searching all the jars on the class path trying to find it. So everything can refer to everything else, either through static references or through core reflection for extra fun. The class path is, in some sense, the ultimate in erasure, right? Whatever you know about the structure of your system, those graphs top-down that we saw, the class path throws it away and connects everything to everything else. And as Mark showed in the keynote, that means conflicting classes and missing classes and generally slow lookup every single time the VM needs to read a class, which is pretty often. With modules, you're telling the compiler and VM what you know about the structure of the system, and finally they hear you. Speaking of the compiler, let's see how you run it. We've got the JAX and jar files in the lib directory where they've always been, and we treat them as automatic modules simply by putting them on the module path, that's -mp. So to Java-C, we specify where the modules are coming from by setting -mp, the module path to lib. No changes to the lib directory, just -mp for module path to Java-C. We've got the myapp and mylib source code in the src directory for myapp and mylib, yep. And we tell Java-C about this src directory with the new module source path option. And the reason that new option is necessary is if you look at the structure of the src directory, there's a new level in the directory hierarchy at compile time for modules. So it's src, then module name, and then the code in the module, moduleinfo.java, and the package hierarchy. And so instead of naming the package hierarchy for each module independently to Java-C, you just say minus module source path, point to the top level src, and it will go and find, Java-C will go and find the modules, module sources in that directory. As a good citizen, I'm specifying the -d option to Java-C to set the output directory for the classes. So the result is class files in the mods directory. The shape of that output directory is the same as the shape of the source directory. So actually, if it was source myapp stuff and source mylib stuff, it'll be mods myapp class files, mods mylib class files. Then we run jar to build mylib.jar based on the classes in mods mylib. We run jar to build myapp.jar from the classes in mods myapp. And because both those jar files will have the moduleinfo.class files that we compiled, we call those jar files modular jars. You can take those jar files, I guess you'd have to have some other some other compiler flags, but those jar files, you could run them on JDK 8, where the moduleinfo class file will be ignored. And if you run them on JDK 9, the modular runtime detects the moduleinfo.class files, and you're off to the races. You'll see that when we create the jar file for myapp.jar, we also specify the main class, which is the same class as before. The result is that you can run your modularized application with a command line that is considerably shorter than before. All the stuff from CP, -CP in the past, is now wrapped up in the moduleinfo.class files in myapp.jar and mylib.jar. Remember, the explicit modules are located in mlib, and the automatic modules are I guess that should be mods, shouldn't it? Yes, that should be the mods directory. And the old JAX and jar files, they're still in the lib directory, but we've put the lib directory on the module path so they become automatic modules. So to recap, we modularized an application with two techniques. First, we built modular jar files for our own code by writing and compiling moduleinfo.java files. And the second technique was to create automatic modules for third-party code simply by putting their jar files on the module path. If you like, you can think of that as top-down migration. We asked the questions first, what does our application require looking top-down? That should obviously make you wonder if there's such a thing as bottom-up migration, and for that, Alan will speak.
All right, thanks, Alex. Okay. Can you hear me? Okay, so this section is, we will mostly forget everything that Alex has showed us in the first part. I'm going to wear a different hat. Alex was wearing the application developer hat.
had a bunch of libraries that he was depending on that were not modules. He's made them modules through a bit of black magic and a black shirt. I am now going to look at it from the other perspective of, I've now got the library maintainer's hat on, and I am going to take the exact same example, these 3 Jackson libraries that we just picked for this example. I am going to see what it would take as the maintainer of those libraries to move them to modules. So I'm moving essentially from the bottom up. Alex was the top down, and we'll bring them together later on in the slides. So what I want to get to is this. So the color coding we've been using in these slides is green is modules, orange was just the jar files. So I've now, in this slide, turned each of the 3 jar files that I had into modules. Now, I'm making the same assumption that Alex did in his part of the presentation. I'm assuming that these are good candidates to become modules. There's no cyclic dependencies. I don't want to do any significant refactoring of this code before I turn them into modules. So we'll do the same thing that Alex did, is we'll go from 1 jar to 1 module. Exactly like we did in the first part of the presentation, we asked the same 2 questions. What does the module require? What does it export? We've got 3 jar files that we want to make into 3 modules, so we're asking 6 questions. What does Jackson Core require? What does Jackson Core export? What does the data binding module require? What does it export? What does the annotations jar file or module, what is it going to require and what is it going to export? Now, in order to help me understand what it requires, I'm going to bring out and wheel out the JDEPS tool again. I used it in some of the other sessions earlier on this morning to be able to look at static dependencies. One of the other useful things is when we're moving to modules, we can also use it to see what it requires. So I'm running JDEPS just on the 3 Jackson jar files to get a feel for what they depend on. There are some dependencies between the Jackson jar files themselves, and they have some dependencies on some platform modules. Everything depends on Java Base, as we said in the earlier session today. In these modules, we can see the data bind module has a dependency on Java SQL and Java XML. Now, let's see. This is what it looks like in the graph. So in this morning's session, we were actually building up a module graph, a dependency graph that we turned into a readability graph. This is what the dependency graph is going to look like for these 3 modules that I'm going to make. I'm going to wheel out JDEPS again, because JDEPS has a couple of other useful options to help me generate the module info for these 3 jar files that I'm going to make into modules. Yes, I can actually go and dig out my favorite editor and IDE and start typing in the module info, but JDEPS can help me by at least getting me started. So I'm going to run the JDEPS with this option called gen module info. I tell it a source directory where I wanted to generate the module info.java files into, and then the jar files that I want to generate to generate the module info for. So the output that is being shown is it's generating 3 module infos, 1 for each of the jar files that we're going in to make into modules. So this is really useful. It's going to give me a starting point for the module infos that I want to write. So I'm going to look at one of these now. We'll just look at it for the data binding one, because that's the most interesting one to look at. And we'll see what JDEPS generates for that jar file. And this is what it generates. So it generates the module name, which is derived from the jar file. It writes a requires for each of the dependencies, so it's figured out the platform modules, the other modules that it depends on, and then there's an exports for every package in the module. As Alex said in his part of the talk is, when you look at a jar file, you have no idea what the exported API is. Now, we'll talk a little bit about exports in a minute, but I just wanted to point out that in this example, we can see there's a requires public on each of the 4 modules that it depends on. When we talked in the intro session this morning, we talked about using requires public when when you depend on something, when you start using the signatures of that module, or sorry, of types in that module in your API, you don't want consumers of your module to then have to go and, oh, well, you depend on that, therefore I have to also go and depend on that. Remember we had this morning about the implied readability. So JDEPS has figured this out and generated requires public for each of these 4 modules, because the exported API, which is all types, or sorry, all public types in this module, must have signatures for these for types in these modules in the API. Okay, so JDEPS has generally got the requires correct, but it doesn't know what to do about the exports, because remember our question is, what does it require, what does it export? It has generated an export for every single package. Now, how do I figure out what is exported? Well, as the library maintainer, I should know these packages are part of my API, these other packages over here are purely implementation, nobody should be calling them. And so what I might do is edit that module info, and I'll start removing some of the lines that I think. So, by the way, I'm not a maintainer of this library, but I'm making a guess here that all these little impl packages that are in this library are not for the users of my library. So I'm deleting those lines from the generated module info, so that I've ended up with my exports that is a subset of the packages in that jar file that we will make a module. I'm now going to move on, and I'm actually going to compile this. So we have generated the module info into the source tree of the 3 modules, what will be modules. I'm going to compile them with a similar JavaC command to Alex used. This is a multi-module compilation. That is what this module source path option is about. I'm being a good citizen, specifying the output directory mods. That's why I'm going to compile all the modules into this mods tree. And I'm going to run the jar tool and create a modular jar for each one of those 3 jar files. I'm using a couple of advanced options here. I'm specifying the version of the module at packaging time. The module system doesn't care about versions, but it supports adding versions and other metadata at packaging time. And that's what I'm using with the jar commands here. Now what have I got? I've got a nice clean module graph from the bottom up. I've got my 3 Jackson modules, and the dependencies are very clear among those modules and on the platform modules underneath. I'm now going to run this. Now, running this is a little bit complicated because we still have jar files at the top. The application is still a set of jar files on the class path. The libraries that it's using are modules. The platforms underneath are modules. So I'm going to be mixing the class path and the module path for this scenario. So we touched on this in the intro deck this morning, and mixing the class path and the module path to support migration. And this is a scenario where you need to do this because the application is still on the class path. So let's look at the command that I'm using here. So I'm specifying the module path, where it'll find the modules. That's, if we look in the mlib directory, we'll see 3 Jackson jar files in there. There are modular jars. I have retained part of the class path that has my app and the little helper library, mylib. They are still on the class path. Now, there may be thousands of modules in the mlib directory. How does the module system know which ones you're going to use? Because there's nothing in my app or mylib to say what modules it uses. So this is why we have the add mods on the command line to tell it that we're making use of the Jackson data bind module. So my command line has got a little bit complicated here because I'm mixing modules and class path, but that's okay. For now anyway, we'll bring them all together in a few minutes. Okay, so what have we done here? We've done the equivalent of what Alex has done from the bottom up. Alex went, took the application and the mylib, made those modules, made the modules that depend on automatic modules, We've now gone from the bottom up, and we have just got the Jackson libraries as modules. But we still have the application on the class path. So let us go and see what happens when we run this. And the reason I want to go into this is just to show some of the more advanced topics that one gets into when migrating to modules. So let's run this and see what happens. Oh, I get a scary exception. So this is the second presentation I've done today with scary exceptions. I don't mind doing this because we're so close to Halloween that lots of scary things can actually happen. What is this scary exception saying? This scary exception is something called an inaccessible object exception. Never heard of that. What's going on here? What's going on here is that code in the data bind module has somehow got a reference to some type in a module that it does not read. Why did Alex not have this problem when he was running? Well, this is part of the magic when Alex said that automatic modules automatically read all other modules. You don't get that for free when you're writing your own module. You have control over what modules you actually read. So the data binding module is one that it's a bit of a serializer, deserializer. It's being handed some references to some random module that it knows nothing about. And it's using core reflection or set accessible to bypass access checks. And it fails. And why does it fail? Well, it fails because the data bind module does not read, now, this unnamed module. That's, as I said this morning in one of the presentations, ignore the term unnamed for the moment. Just think of it as class path. Alex will cover a lot more of this in the 5:30 session here today. So, okay. If you understand readability, you understand access checks, you can see why this fails, but how am I, as a library maintainer, going to be able to deal with this? Because I'm always going to be handed types in modules that I don't read. And this is where the reflective API comes into the solution. So JavaLang Reflect is where you'll find things like JavaLang Field and Constructor and so on. There is a new type in the Jigsaw builds, which is JavaLang Reflect module. This is the object that I can actually use to get a reference to the module for a type. There is a JavaLang, there's a method on JavaLang class to get a module's to get the module. So it's a get module method. Now, if we get a reference to a module, what methods do we see? Well, there's a bunch of methods, and you can look at the online JavaDoc and get a feel for it, but you can ask the module what its name is, you can get its original module descriptor, you can do a few other things, but two important methods on this, on the JavaLang Reflect module are can read and add reads. So you can ask a module, do you read this other module? And if you are a module, then you can add a read edge to the graph at runtime, and you can only do it from your own module. So you can as a module read any other module at runtime. So in our example, we're given some type, a reference, given some type in some random module that we know anything about. Then me, as a serialization library or data binding library, I can say at runtime, I need to be able to read that module temporarily. When I say temporarily, it's until that module gets GC'd or whatever. And that, if that type is then exported, then I should be able to access it. And this is how we get a lot of reflective and serialization code to actually work. So what would be the patch to this library to make use of this API? Well, it'll be something like this. I'll find out, I'll be given some class object, I'll call its getModule method. I've now got a reference to a JavaLang Reflect module. And then I will, for my own module, I will add a read edge to this other module. And this is what the add reads method does. I've now added the read edge, so I've changed my code, and what means is that this little green tick here means that I now read this unnamed module. and it means that the code now works the way you expect. So it'll work the same way that it did with Alex when he had these Jackson modules as automatic modules. So this is just part, so the point I want to get across in this part of the presentation is that making the effort to move your code to modules sometimes will require some modification to that code. So we've gone through all of this in the JDK. So the JDK I like to think of as just basically a bag of frameworks. So we've got the JMXs, and we have the JAXs, the JAX bindings, we have the web services, we have all bunch of different APIs in the JDK and JavaC. We've already actually ported every one of these over to modules. So we've already built up quite a bit of experience actually porting these frameworks over to help us validate the API that we have proposed for 9. And once you've been through this once or twice, the amount of effort required is not all that much. The changes tend to be quite small for that code to work in modules. Okay, so let's now try and put it all together. We've got Alex has ported the application jar file and its helper to modules. Pretend that I've gone and ported all of the libraries to modules, and we will try to put them all together. So starting at the bottom, this is what I have. This is my nice module graph. And now we will add the other modules on top, because they're now nice first-class modules as well. And we end up with this nice module graph. So this is quite nice. It's quite clear what the dependencies are. There's no cycles. And of course, it makes it easy to run because everything is modules. Let's assume that they're all compiled and packaged into modular jars in the mlib directory. Then I'm down to the one command. So this is quite nice. Okay, I have so that's mostly what we wanted to talk about porting, migration and adoption of modules. I have a couple of slides just on linking again. There's quite a few questions came up from the intro this morning, but we can actually use the example that we've worked through here and see how this works with linking as well. Okay, so I've got a JLink command here. Module path tells it where to find the modules. I'm going to add one module to this image that I'm going to go and create. Here's my output directory, and let's see what happens. So for those that were here in the earlier sessions this morning, you'll know that what we're generating here is a modular image. This is like a runtime, but it's the JDK 9 version of it. This runtime image is a custom image. It can have standard modules, JDK modules, third-party libraries. It can have your own application. And in this example, I'm going to create a runtime image that has my application and, of course, all of its transitive dependencies. So I've ran this JLink command. I've given it on the module path, by the way, there's 2 directories I've given on the module path. One is where to find the JDK modules. Secondly is where to find the other modules that will need to get linked in, my app, and of course all its dependencies. What's in the modular image? Well, it's got a bin directory where I've got all the binaries. It's got the lib directory, that implementation stuff in there. It has a conf directory with configuration files. Let me look in the bin directory because that's the most interesting one. And I've got the Java launcher in there. And, oh, this interesting one, I've got a My App launcher in there as well. Someone asked about this late in the previous session. So this is generated because My App that Alex generated earlier on has an entry point. When JLink creates a runtime image for a module that has an entry point, then it will generate a launcher for that. So it's generated a My App launcher for this application. When I do my Java list mods to see what modules are in that runtime image, then I've got this small little list. It's got my application, my lib, all of the transitive dependencies, and then just the minimal number of platform modules that this application requires. So that's actually quite nice. I've ported my application to modules. I've ported these Jackson libraries to modules. I've now created a runtime image with just those in there. I can deploy that, which is actually quite neat. And the way we can run that is by java-m, give it the module name, no module path needed because it's all in the runtime image. Or if I use the custom launcher, I can ignore all of that and just do my app, which is nice. Okay, I think that is essentially what we have. So, summary. The most important thing to take from this talk is that you have the freedom to adopt and migrate to modules at your own pace. You don't have to do it from the bottom up. You don't have to always depend on other library maintainers to port to modules first. There is a possibility with the automatic modules for you to move to modules before they do. So you can modulize your application before it's libraries. If you're a library maintainer, then you can actually go from the bottom up and you can modulize your libraries completely independently, which is good. Another thing to learn from this session is explicit versus automatic modules. We were writing module infos, compiling them, creating modular jars. They're explicit modules. I'm taking the effort to migrate those to modules myself. Automatic modules is where we just treat a jar file as a module. That requires everything and exports all of its packages. We just treat it as a module. So you can kind of think of this as two different types of modules. The other thing to take from this talk is that when you make the effort to migrate some library to modules, then there may be some code changes required. I deliberately picked an example for this session that required changes to that code because it was essentially a deserialization library that needed to use a reflective API to work properly with modules. So that's it. Leave you with this one message. Go forth and modulize. Okay, so Mark mentioned about the other sessions. So we're back in here at 5:30 for Alex's Under the Hood talk, which is essentially a continuation of this into another session. And we're back here tomorrow morning at 8:30 for the hack session. And then we also have some repeats of the intro and prepare for JDK 9 Wednesday, Thursday, Friday. More information, links to the project page where you can find all the documents, JEPs, all the other material, mailing list, pointer as well to the early access bills. And that's it. So questions. So right. So what we're going to do for questions is, because this is recorded and streamed, is if you wouldn't mind, if you have questions, coming up to the microphone so that it gets picked up.
So maybe this is not as big of a deal once you link, but let's say you're using module path. What happens if somebody tries to replace they try and export java.lang or your security packages to override your security? Never will happen.
Okay, so someone
inconceivable.
Right. So
which means it's in progress.
Okay, so there's something we didn't talk about today, which is the system module path. That's where all the platform modules come from.
Okay.
You can think of that as coming before the application module path. So we will never look for JavaLang object down the application module path because it's already in Java base. It'll be found there first before everything else.
So how about application-specific stuff? You're providing a libraries, and it's got a security layer in it. Of course, everybody can reverse engineer it, see what the interfaces is, see what the signature is, implement their own,
right.
Bypass your stuff.
Right, but okay. So do you want to talk about hashing? Go. Okay.
So this is an issue that's come up, and you have a.
Sure. So there's more to it than just putting something on the right path and hoping that nothing gets in front of you. A thing that we've prototyped, not just for modules in the JDK, but for use by others if you want, is if you have a tightly coupled set of modules and you want to ensure that your app module only ever uses your security library module from a specific build, then when you package them, you can bake a strong hash of your security library module into your app module, and the module system will validate that when it resolves. And if that validation fails, just...
That's what I wanted to hear.
Yeah. Okay. So integrity is something we take pretty seriously, but it's optional because in many environments,
right.
You have complete control. You don't
Depends
care.
if you trust your consumers.
Yeah. So between that and a couple of other consistency checks, nobody will be able to redefine JavaLang.
you try out the Jigsaw builds, have a look at the jar command, look at the help option, you'll actually find a hash dependencies option in there for generating those hashes when you generate those module jars. So worth trying out.
So for a dependency injection framework like Spring, how are you handling if it needs to get access to something I don't export? Is there a add export or something in the reflect?
So repeat the question so I understand. For a dependency injection framework such as Spring, how are we dealing with it when it needs to inject into something that's not exported? Right. Well, that won't work. If you're using a framework that needs to do deep reflection, then you need to at least export the relevant packages to that framework module with a qualified export. Okay. Or maybe just export it generally. It's up to you. Okay. There is intentionally no reflection API for breaking an encapsulation boundary. The only way to break an encapsulation boundary is from the command line, because we assume that if you have access to the command line, you have godlike powers, you can do anything anyway. But we're trying to take the stand that integrity from within the running Java process is to be maintained.
Okay. Thanks.
So how can
speak up into the mic, please?
Okay. Does this project Jigsaw, is it compatible with OSGI?
No, it is not compatible with OSGI, but OSGI will run just fine on top of it.
And then how about does it also support hot deployments like OSGI style?
Jigsaw, it does not directly address hot redeployments, but neither does it get in the way of other mechanisms that might do hot redeployments. There is a certain level of dynamism in the layer mechanism, which is probably the most advanced concept in Jigsaw, where you can spin up another layer of modules and tear them down later. But that's not necessarily what people mean when they talk about hot redeploy.
So what about the web project like WAR files?
You would have to talk to somebody who works on Java EE standards. So we talk to people who work on the EE specs. Okay. Long term, we hope that there will be a way to have a modular WAR file, but exactly how that will look, we don't know. But we're trying very hard to make sure the foundation we're building will be good for that.
Thank you.
What about JNI? If I have a module that needs DLLs or something, SO files or something like that, can I bundle it somehow with my module or?
Yes, sir.
Okay, sure. So modules can have native code, and it works exactly as it does today. We have some additions to the JNI API to be able to things like get module and so on. You can link modules that have native code into runtime image. That all just works fine too.
Hi. So you are using the jar tool to define the main class in a module. So I would have expected it in the module info.java. So why isn't it there? And you need a second tool to define it.
Sorry, I didn't quite hear that. So why do we need a tool to set the main class?
Yeah. Yes. So why is it not just in the module info.java?
Right, this is the extended metadata. Do you want to take this?
So we've tried hard to keep the part of the design that affects the language and the virtual machine as simple as possible. They contain only the essential information that's needed by the compiler and the VM, and leave other things, especially things that are often sort of reconfigured in your build system from time to time, and they aren't an essential property of your program. If you're thinking primarily in Java terms, you've got methods and fields and classes and interfaces and packages and modules that compose those, and that's all that's really appropriate to talk about in the language in the VM. So from that point of view, saying, well, what's your main class? Well, the language in the VM, the VM does need to know it to start up. So truth be told, we've gone back and forth on this. In earlier prototypes, we actually did have the main class in the module declaration. So in your source code, you could say, main whatever class name. But then that got tricky because, especially once we had JLink, the linker tool that could make a custom image, well, okay, you've got a main class, but you usually don't use the whole name of the main class as the name of your command line launcher. You want some short name. Now, do you want to put that short name in your source code? Maybe, maybe not. I mean, what if it needs to be different on Windows and a different build for a different OS? It becomes much more of a build time configurable thing, and so we just took the whole main class concept out.
Okay.
But it's still there, and when at packaging time, when you make a modular jar, you can say, "This is my main class," and you can also say what the name of the command should be.
Thanks.
Hi, thanks for the talk. I wanted to talk about module exports. Since you mentioned, and you had in your example, packages, I'm assuming that once a package is declared, everything below it automatically, sub-packages, will be auto-exported. They will not. So they explicitly need to be...
No, sub-packages in Java are really, they're nothing more than a syntactic convention. If a package is a sub-package of another, means nothing. They have no semantic relationship other than that they share a name prefix. So there's no export of sub-packages. There's no export, com.foo.bar ***. Okay. You really have to ask for each one.
So for very large projects that have a lot of packages, there is a certain level of maintenance required to go and scan and figure out exactly what requires to be exported.
Well, that's what JDEPS is for, and from a software engineering perspective, well, it's a good thing to be aware of. Okay, this is my module. Here are the packages I'm exporting, and therefore all the others I'm not.
Gotcha. All right, thank you.
Hmm?
If you want to modularize a library, that depends on a third-party library that hasn't module support yet. Is there a way to go forward without assistance from that third party? Yeah. So when you write the module info.java file for your library, you are the library maintainer. Welcome. We hope you enjoyed the second half. It was for you, right? So if there's a module, if you've got some jar, Apache Commons logging or something, that is not yet a module, you can still require it, but in your build and test, and indeed in your documentation, you will have to tell your end users to put it on the module. To put it on the module path, to put Commons logging jar on the module path, so that when your module is resolved and that requires Commons logging clause is seen, the module system can find from the Commons logging jar, oh, this is an automatic module, as if the Commons logging people had modularized it themselves. If you don't want to require, I shouldn't say require because we say requires in source. If you don't want to cause your end users that trouble, then, and in other words, you just assume that the jars that you depend on are just going to be on the class path. They aren't going to be in named modules, even automatically, for some time. It depends what use. I can offer you some techniques. It depends what use your library makes of those third-party jars. If you're using them widely and you have many references in your code to their types, then a reflective solution is not going to be right for you. If there's a third-party library that, and we have this, for example, bootstrapping the JDK, if your library depends on another library only in very particular ways, and perhaps the other library isn't even present, right? Perhaps you can work without it. I show an example of that in the next talk. Then you can do a class.forename on one of its types, get its module. Even though it's on the class path, you can still, as Alan showed, get that unnamed module. You can call add reads for your library to then read that module, and you can invoke its methods reflectively. It depends how your library is using the third-party library. Well, how the third-party library is using the fourth-party library.
But at the same time, don't forget, if you could have release notes that would say, for example, make sure the jar file I'm giving you is on the module path, plus Commons logging, put that on the module path, or just leave them both on the class path, because that will still work in legacy class path mode.
A somewhat unrelated question. How do you envision tools like Maven to migrate in this sense?
It's a fifth talk.
That's a whole other talk, but Jay, I mean, Jason Van Zyl is in the module system expert group, and we hope to work with all tool vendors to make sure that there's support for this stuff when Java 9 comes out.
But there's no concrete plan at the moment how that will work.
I don't think there is, no.
Okay.
It's a bit early for that, but I expect there will be.
When you let me just make a point about that. The day that JDK 8 was launched with lambdas in it, not only did Java C and NetBeans support lambdas, Eclipse, the same day, supported lambdas. Modules are not like that. They're not a little language feature that an IDE editor and type system can support and give you red squiggly underlines, and then the feature is supported. You can see modules are about the tools and your scripts that are currently setting class paths. Sorry about that. And it's a much more distributed problem, so that the day JDK 9 comes out is really the start of the answer, rather than everyone can all of a sudden use modules up and down for free.
Can you come to the mic, please? No, just come to the mic, please. We're streaming.
Sorry, I'm Manfred Moser. I'm presenting with Jason about Apache Maven on Wednesday. But I mean, in terms of the multi-module support, this multi-JDK, we have, like some of the Maven committers have done a prototype implementation where in a multi-module project you can already create this multi-JDK jar kind of artifact. That's already possible. We are working towards improving that in a single module and stuff, but there's ongoing work happening basically.
So when you call a module add read, does it matter what context class loader is set?
We have no interest in class loaders.
Okay.
We didn't say. Well, I'm going to go with that because it makes the point. We didn't say the word class loader in this presentation.
Okay.
My next talk, I cover class loaders a lot, actually.
Okay.
Primarily to say how little I am, how little interested in them I am. It's not that we get rid of them, but the module system is somewhat, I don't want to say it's orthogonal to class loaders.
It's almost orthogonal.
Yeah. Okay. There are still class loaders you can't not load a class in a class loader. But they are not the primary, they're something we suffer. They're the primary mechanism. They don't provide encapsulation, right? They're pretty dumb on their own. They let you get into cycles. It's a very low-level mechanism. If you've built a module system on class loaders, you've been relying on a very low-level mechanism, which is why you'll see I introduce some other constructs. One question.
Is it possible to create multiple modules for a single jar? Or will it be?
Single jar.
Do you mean multiple modules in a single jar?
Correct.
No, but you're the third person to ask that question in 2 days.
Oh, we have
Uber jar with multiple modules in it right now. No, but it seems like it's something we need to think about.
Okay. Thank you.
Make an image.
Well, that's not always the right answer.
Thank you.
Currently, it's never the right answer. Because you can. Right.
Well, we should split it up.
Yeah. Are we out of time?
Yeah.
Okay.
Thanks very much.
Thank you.
Actually, this one can take directly HDMI. Okay, right? Yeah, I'll connect it. Thank you. Also, I have a very loud voice, so you may want to bring it down based on what you find out. Okay. Yeah. Very loud voice. I have a very high pitched voice. Oh. Yeah, you don't feel it now, but when I start speaking, yeah. Thanks. Yeah. Thank you. No audio. No, actually. Thank you. There we go. Oh. There we go. Two more. Yeah. Yeah. Awesome. It's on this side here. That should do it. Is it a blank? There we go. 1, 2, 3, 4 seats. Fourth row. All right, let's get started. Welcome to the session on programming with Lambdas. My name is Venkat Subramaniam. We're going to talk about what Lambdas can do for you, what we can use it for. So let's get started. This is one of the best things that's happened in Java in a very long time. If you really look back in time with Java, there's not been such a great improvement in the language level for a very long time. Java 5 had some questionable features. Java 6 really didn't have any. Java 7 had a few features, but Java 8 is really a game changer. So one of the most interesting things about Java 8 is Lambda expressions. So the first question, of course, is what in the world is Lambda expressions? Well, Lambda expressions are anonymous functions. They actually are cute little anonymous functions. And they really make our lives a lot easier by reducing a lot of ceremony that we have normally in code. And as a result, it becomes a lot easier to work with them. So this leads to a different style of programming than we are used to. Most of us are used to an imperative style of programming, but now we can start using more of a functional style of programming with Java thanks to Lambda expressions. So to understand this, let's take a look at a series of examples and see how this changes the way we do things. So I'm going to start with a little example, the one that we are all extremely familiar with, one we have done a million times over. And then we're going to redo this several times, maybe about 6 or 7 times. I'm going to refactor this code, and we're going to see how this is actually going to work out. As you can see, I'm not using any slides here. I'm going to just talk about stuff and code. If you're interested in downloading the code examples, you're most welcome to download them from the URL up here on the line number 5. But you don't have to rush it to write it down. I'll also list this towards the end as well, so you can note it down if you're interested later on. So let's start with a little example. How does it feel to work with Lambda expressions? But I'm going to first start with something we're extremely familiar with, and then we'll move forward from there. So what I'm going to do here is start with just a little example of, let's say, a list of a few numbers. So I've got a few numbers on my hand, and I want to iterate, loop through, and print these values out. So how would I go about printing them? Well, this is something we're all so used to. We have done a million times over. So I'm going to say int I equal to 0, I less than numbers dot, is it length? Size? Count? Length? Is it length? Are you sure it's length? Well, size, okay, size. Oh, wait, is it less than or equal to? Is less than. On the days you don't think about it, it's called the off by 1 error day, right? So we have to go through all of that. And then, of course, what do? We say numbers dot get, and then, of course, I, and, of course, we have the result. Now, people will tell you this is a simple for loop. But I got the word really mixed up. That's not the word simple. That's the word familiar. And there's a very big difference between the word familiar and the word simple. For example, my in-laws, very familiar. But I would never use the word, simple with them. So the point really is that we are confused between familiar and simple, but there's a very big difference between the two. Familiar is something we have looked at a lot, but doesn't mean it's actually easy to use at all. So this is an example of a familiar code. But if you're into design patterns, there's a really good name for this particular pattern. It's called the self-inflicted wound pattern, because we have done this over and over, and we've been hurt by this so many different times. Well, it works, but this is called an external iterator. Let's do this one more time. We can simplify this quite a bit. I'm going to say int element coming from numbers, and of course, I'm going to just output the number a lot easier. Well, we can clearly say this version is simpler than the previous version we just saw a minute ago, and of course, it removes quite a bit of ceremony. But both of these put together are called external iterators. So what is an external iterator? An external iterator is like having a rude dog. You say move and it doesn't move. You got to push it every step of the way. Well, in this case, of course, rather than using an external iterator, for a change, we can switch over to what are called internal iterators moving forward in Java. So how does an internal iterator work? It's kind of like throwing a frisbee and the dog goes to get it. You don't have to do extra work to really iterate. You simply put the iteration on an autopilot. It becomes a lot easier to work with. So let's take a look at an example of how we could use an internal iterator in this particular case. So the internal iterator in this case, internal iterator simply says in this numbers, I'm going to call a method on this called a for each method. So look at the first difference already. Rather than passing the numbers to a for statement over here, we are instead calling a method on an object. Well, we know what happens when the minute we call methods on objects. We immediately can start enjoying polymorphism, and polymorphism is the real core behind a lot of extensibility and flexibility that we often get. So this has a really good power behind it already. When something is polymorphic, there are certain things we get almost for free. We don't have to worry about how it's implemented. We rely upon what we want, and the implementation kind of falls in place. One more thing, of course, is if you look at the for loop that's up here, what does it give? It gives exactly what we ask for, a sequential iteration. But looking at this for loop, though, we don't quite know what kind of iteration we perform. This could be sequential, this could be lazy, this could be concurrent, parallel, what have you. So there's a lot of flexibility we can get out of it. But of course, we want to implement this internal iterator. How do we go about providing this internal iterator? Let's give it a try. So for that, I'm going to bring in the first package we're going to use here, a function package that's part of Java 8. And the function package contains a few interesting functions that we can actually use. And these are called the functional interfaces. So I'm going to say a new consumer integer right here. And then, of course, within this, I'm going to provide a method, a public, let's say, in this case, void. and I'm going to say accept an integer value, and then I'm going to output the value that we got on hand. So if you notice in this case, that produces the same result as well, but this is an internal iterator compared to the external iterator we just saw a minute ago. Well, the good news about this is we are not focusing on the iteration itself. We simply said what we want per iteration, and it takes care of the rest for us without having to put in the effort to manage the looping itself. I know what you're thinking. You're thinking, this could be the best thing ever, but if that means I have to write yet another anonymous inner class, heck no. Is there anybody here who wakes up in the morning and says, yes, I'm going to go to work today and write anonymous inner class yet again, right? Okay, there's always these two people. We'll talk about this afterwards, right? So the rest of us, of course, absolutely not. In fact, you would call the boss and say, I feel real sick today, and cancel the day, right? So that's how it feels about it. So what can we do in this case? Well, if you look at this code, though, this is a really good example of the ceremony that we have gone through for years and years, about close to 20 years of programming in Java. And ceremony really damns us. As my good friend Stuart Holloway wrote in his blog, it really becomes extremely hard to work with ceremony. Is there anybody here who really enjoys ceremony? I don't think so, right? Because ceremony is really what you have to do before you get to do what you really want to do. And then all the excitement is gone. Life kind of gets sucked out when you have to do ceremony. Well, if you look at this code, what's the most important part of this particular code? There are only two important parts right here. The first one, of course, is the parameter that you're passing to this function. Clearly, you want to know what you're going to work on. And the second thing in this function is the body of the function itself. Other things in this code are pure ceremony. In fact, I'm going to highlight the ceremony right here, and I'm going to delete the ceremony right there, and I'm going to just replace this with a little arrow, and then remove the rest of the ceremony from code, and we can see the code is still working. So we took the lambda anonymous inner class and changed it to a lambda expression right off the bat, and you can see that the lambda expression has two parts to it. The first part of a lambda expression is the parameter list to the left of the arrow, and the body of the function is to the right of the arrow. So there is the cute little anonymous function we are looking at. So we can see that this particular function does exactly what we wanted, but with a lot less code as well. So we could stop right here and celebrate lambda expressions, but thankfully there's a little bit more we can do with this. If you look at this code for a minute, there is the iteration that's happening, which is really nice. But of course, there is something else we did, which is a tradition in Java. Notice we said integer value. Now take a wildest guess for a minute. If you are iterating over a collection of integers, and if you were to pull an element out of it, what in the world do you think value would be? A dog? Real, surely not. It's going to be an integer, so we clearly know what it's going to be. Well, you know this and I know this, so why bother saying this over and over? So for the first time in a long time, Java is finally intelligent. So you don't have to specify what the type is. You can let go of that. And you can see the type inference kicks in, and you don't have to say the type. So lambda expressions also have type inference with them. So very generously, you can leave out the type information quite easily. So that removes the ceremony quite a bit, of course, but then comes a little bit more ceremony. Why have this parentheses? After all, we can get rid of it. So we can see that we got rid of the parentheses in this particular code, and you can see that's really becoming smaller as well as we speak. So for a single parameter argument, you can let go of the parentheses as well, so that reduces quite a bit of ceremony. Well, this is pretty much, we can stop at lambda expressions, but there is just one more thing we can actually do. If you look at this particular lambda expression for a minute, we are receiving a value, and we are simply passing the value to the print line function. Now, clearly, you could have done something more intelligent with the value. For example, you could have added a 1 to it, or you could have doubled the value and printed it, whatever it is, but the point is, we didn't. And so all we did here is, it's a garbage in, garbage out. We simply received the value and we passed it down. So if you notice, the 15th time you write this lambda, you're going to get pretty angry about it, because that's a lot of noise to do almost nothing other than passing it through. So as a result, this is going to become really boring after a while, and this becomes really stupid. But one thing we have learned over the past several years is Java programmers never write stupid code. Instead, they invent IDEs to vomit stupid code. So the next thing you know is people are going to be tweeting each other, hey, what's that IDE shortcut you're using to do the stupid code? And they knew this was coming. So they decided to eliminate this kind of redundancy in passing the parameters. And as a result, they said, if you're receiving the value and simply passing it down, you can then remove that value from the redundancy, and you can replace this with a double colon, and that becomes what's called a method reference in this particular case. And so in this example, we use a method reference rather than going around and using the lambda expression itself. So we refactored this code about 7 different times, as you can see. We started with the most painful and familiar for loop to begin with. We refactored it to the traditional for each. Those two, of course, are external iterators. And then we said we can trade this to an internal iterator, though that really smelled a lot, but it gave us the benefit of the internal iterators. Then we got rid of the anonymous inner classes, refactored that into lambda expressions. Then we got rid of the type information and used type inference. And then, of course, we got rid of the parentheses and made that a little bit more concise. And then for simple cases where it's a simple pass-through, we decided to use a method reference rather than using a lambda expression itself. So as you can see, we go from a verbose code to something extremely concise. This can be very powerful in writing code because we don't have to endure a lot of ceremony in code. It gets to the point where the code becomes very easy to read, very expressive. We're going to see a few more examples of this along the way as we go through and look at examples. So we'll continue further and take a look at it as we go through a few more examples. So we saw the benefit of this. But one of the most important things here is we go from an imperative style of programming to more of a declarative and functional style of programming. So what's the biggest difference? Well, the difference is, well, let's take a look at an example to understand what the difference is. Let's change the problem just a little bit. Suppose we are given this collection, we are told total the, let's say, double of the values in this collection. So that's basically the problem given to us, total the double of the values in this collection. How would we do this? Well, first of all, we'll start with result equal to 0. And that's our tradition, right? We define where we want to store the result, and we will display the result when we are done. And then what do we normally do? We can say for int element coming from numbers. And then what would we do? We would say, oh, well, the result is going to be plus equal to e times 2 because we want to double the values and then total them as well. Well, that is a code that we are all used to, I would assume. Anybody who has written code like this before? Sure, every one of us, right? Absolutely. But the more important question is, how do you feel writing that code? Really dirty, right? In fact, you go home after a very long day, children come running towards you, you say, don't touch me, I gotta go take a shower first, right? It feels like that. Actually, it's even worse than that. Anybody who works from home here? A few of us, be very careful. Never leave this code on your screen and walk away, because if the children come and look at this, they come to you and say, that's what you do for a living, right? And so it gets extremely, really hard for you to convince them to take on to our field. Well, this is a lot of ceremony. This is called primitive obsession, a lot of code we have to write to get simple things done. But this is a sign of what is called an imperative style of coding. So this is called imperative style. Well, what in the world is imperative style? There are two symptoms or smells of imperative style. The first is you say, in this case, you say how over and over. So that is the very first sign of imperative style of coding. The second thing is mutability. And let's take a look at both of those for a minute in terms of how that feels in this. But I'll write a functional and declarative style before I come back to that. So let's write a declarative and functional style. And I will mention the difference between these two in just a minute. So what I'm going to do now is I'm going to say output and numbers.stream. Think of a stream as a fancy iterator, if you will. And then once we get to this iterator, I'm going to say, I want to perform a map to int, and given an element, I want to perform the element times 2, and then I want to perform a sum operation on the result of this particular collection or the logical collection, and return. You can see that it produced the same result as the other piece of code. However, take a look at this code for a minute. Now, if you look at the top code for a second, we had to write quite a few things to get the same exact result. On the other hand, if you look at the bottom code, we said given the collection of numbers, double the values and total. Notice how it reads exactly like what you really want to do. So the very first sign of declarative style of code is you mostly tell what and not how. And the second thing is no explicit mutability. Now let's take a look at these two for a minute. Let's talk about mutability for a second. If you notice this particular code, notice on line number 11, we repeatedly modified the result over and over and over. If I turn up the volume of the computer and run this program, you will hear the variable result say ouch, ouch, ouch on this line of code. You are constantly mutating it. And that's one sign of imperative style of code. You do mutation over and over. If you look at this code in the bottom, there's a bit of a good news. No variable was tortured in the making of this result. It's a very humane code, as you can see. So we avoid mutability, and what happens when you avoid mutability? The code becomes easier to explain, the code becomes easier to understand, we have fewer errors in the code, and it's also easier to parallelize a code which doesn't have shared mutability in it as well. So overall, this has a lot of things going for it. The second difference is, in a declarative style of code, you say what you want to do rather than saying how to do it. If you look at this code in the top, let's read through this in English and see what we are doing. First, set a variable called result, initialize it to 0, please. Take a value e, which is the first element in numbers. Go ahead and get that value, double it, and then, of course, add it to the result value, put it back into the result. Now get me the second. That's very tiring, isn't it? So in other words, imperative code is like talking to a toddler. Now, the first day you talk to a toddler is very cute. You are like, wow, this was awesome. I spoke to this toddler, how cute. And the next day you meet the toddler, you realize you have to say the same thing again. Don't walk slowly, please. Look where you're going. Don't step on the cat's toe. Please hold it with both your hands. And then you realize the third day you have to say the same thing to the toddler, and you realize this is going to continue for the next 18 years. And that is the way it feels, right? So imperative code is like, working with a toddler. It becomes tiring after a while because you've got to do this over and over and over. Well, a functional style is like talking to an adult. Well, actually, let me rephrase that, knowing some adults I know. It's like talking to a responsible adult. So it becomes a lot more easier to express the code, as you can see. So this is an example of how the code is very expressive, and that is one of the symptoms of a declarative style of programming. Now, of course, we keep using the word declarative, and declarative is where you say what and not how, and you don't have explicit mutability. But then what in the world is functional style of programming? Well, functional style is also declarative, but there's a little bit more with functional style. In functional style, in addition to being declarative, you also use what are called higher order functions. So a normal function is a function that receives objects as parameters. On the other hand, a higher order function can receive other functions as parameters as well. This is a good example where we actually see both of those types of coding. Look at line number 24 for a minute. We are calling a function called sum. I would argue this is a declarative function because you say what to do, which is to sum, and not how to do it, so it is declarative. But notice you're not passing any objects to this function, so as a result there is really no concept of a higher order function in this case. You're not passing a function to this function, so this is not really anything to do with functional style of programming. This is simply declarative, as you can see. On the other hand, if you look at the map to int function, this is both declarative and functional at exactly the same time. If you notice the first here, you are declarative because you said what you want to do, which is to double all the values in this collection. But on the other hand, notice you're passing a function to this function, and this is actually a functional style. In other words, map to int is a higher order function in this particular case. So that gives you an idea about the difference between the two styles of programming. While both give you exactly the same result, one is much more concise and more expressive than the other one doesn't have explicit mutability as well. So we saw some of those benefits on our hand. So this gives us an ability to move forward with a next power here on our hand, which is called composing functions. So in other words, think about, oh, question, please go ahead. So the question was, how do we debug? I don't quite spend my time putting bugs in code. I don't know the answer for it. Well, so a better question to ask really is, why do we think debugging would be really hard? So let me postpone that question for you. And the reason for that is, you can put a breakpoint and you can step through the code like you do always. That's not a problem at all. And IDEs will allow you to put a breakpoint and step through. So that's not a big deal. But there's something else that's going to make debugging a little bit of a challenge, but we haven't covered that yet. So lambdas are a little intimidating. That's the question. One of the reasons is we are looking at something that's not very familiar to us. And this is a human nature. Every one of us goes through this. When we look at something that we're not familiar with, we don't like it as much. And that's very natural, and we got to just get over that kind of fear that we normally have. But there are really good reasons why we should be concerned about, but we haven't gotten to that yet. So stay with me, and I'll talk about that in just a few minutes after the next topic. So given this, we want to talk about composition, which is a really powerful concept here. And I want you to think of the word pipelining. So pipelining is a really good way to think about this. You take a collection of values and you pipeline them, applying one transformation after another, and you keep going through these transformations through your code. That becomes a lot more easier and effective to work with it. So to understand this, I'm going to take this collection, but I'm going to make a slight change to this collection. I'm going to say this is going to be a collection of 1, 2, 3, 5, and then 4, 6, 7, 8, 9, and 10. So now I'm going to change the problem on hand. I'm going to say, given the collection we have, find the double of the first even number greater, let's say greater than 3. So I want to implement this code in the imperative style first, and then I'm going to implement this in the declarative style and see how it goes. So I'm going to say result is equal to 0, output the result, the traditional imperative style. And what am I going to do? I'm going to say for int element coming from numbers, and then I'm going to say here, if element is greater than 3 and element mod 2 is equal to 0, then I'm going to say result is equal to element times 2, and I'm going to print the result out. Is this correct? I hear no. What's missing? A break. Okay, I put a break. Is it correct now? So it doesn't matter. Given list. We don't care about the sorting at this point. It's a given list as it is. So is it correct? Notice you went from it's not correct to I'm not sure anymore. That's a sign of imperative code. Because imperative code gets you worried very quickly, right? And imperative code, so if you look at imperative code, there is usually a sign of imperative code. In fact, it's really wonderful if you can do this. Give an imperative code to somebody, but sit in front of them and watch their eyeball. The eyeball does this. It goes like this for a while, and then comes to this point, and that point where it shakes is called the point of confusion, right? And then usually you have this like, okay, we see this. Well, that's what you go through. You're trying to analyze this code over and over, and that can be very frustrating. In fact, if I run this code, notice it gives us the right result, which is 8. But typically, here is what happens. A few weeks goes by, and you know who walks in? The person called the tester. And usually my tester will walk in announcing, hey, Venkat, your code sucks. And I usually tell my tester, don't tell me the obvious. What I want you to tell me is, how does it suck today? Because it seems to suck different every single day. So the point really is, this code sucks. We don't know how it sucks. We'll figure it out in a minute. Well, let's try this again. Let's say we're going to write this code. This time, though, we're going to say numbers.stream one more time. So we brought in the stream. But what am I going to do this time? I'm going to call a function called a filter. And we saw a map earlier. Map did a transformation. But a filter cherry picks values for you and drops off values that don't meet the criteria. So in this case, given an element, give me elements greater than 3. And I'm going to say filter given an element mod 2 is equal to 0, even numbers. Then perform the map function. Obviously, we want a map. In this case, given an element times 2. But then I'm going to say find first and ask it to give me the first element out of this collection. So you can see the beautiful pipeline that happens right here. And notice the dots being aligned vertically. You take the collection first of all, you filter all the values greater than 3, then all the even numbers, double them, but only return the first value in the collection. If you run this code, the code not only gives you a result, but it also reveals the problem with the previous code. Notice the previous code, the imperative code, gave us a result of 8, and my tester didn't really like it. But why? Because notice the declarative code now says not 8, but an optional 8. So what does that mean? The code gives me a clue that there are times there may not be a result at all. How so? What if the collection were empty? What if the collection had no number greater than 3? What if the collection had no even number at all? For all those cases, the top result was 0, but the bottom one would be an optional dot empty to tell me that I may not have a result at all. So you can see how the code is more transparent. But of course the question is, how in the world do I get the real result out of this function? I do have to warn you, this is one of the most threatening functions in the JDK. It's called or else. And then you can specify an alternate value, whatever you want to get, and you can get the value out of it. So this gives you an idea about how to use this code. But this is an example of a code which is, again, declarative, very highly expressive, very transparent as well, and seems to do what we exactly want it to do. But of course, this brings up the question of one other question we all are often concerned about, but what about performance? Are we not going to lose performance in this case, especially if you're going to be doing this work over and over and over? Well, let's understand this for a minute. Let's go back to the code in the top for a minute, and we will analyze the behavior of this code before we go any further. Well, we know that Java has wonderful short-circuiting, and we know that given collection of numbers in the sequence, and remember lists are always ordered collections, so you have 1, 2, 3, 5, 4, 6, 7, 8, 9, and 10. So we come in here, let's count. I have a value of E is 1, 1 greater than 3, no, 2 greater than 3, no, short-circuited, 3 greater than 3, no, 5 greater than 3, yes, is 5 even, no, is 4 greater than 3, yes, 4 even, yes, double the value 4, break out. So there was 8 computations that we performed in this code, and so we can definitely agree that the imperative style, so imperative does 8 units of work. Not all units the same, but that's roughly what we care about. So that's 8 units of work. Now clearly, I'm going to tell you this code is so cute, so beautiful, so elegant, but I want you to pay 5 times more. You're going to say, get out of here. I wish you had told me this when I came in here. I would have turned around and went left, right? So clearly we don't want to pay an extra price. But let's see hypothetically what this may be. We take a collection of 10 numbers. We are checking if any of the numbers are greater than 3. Oh boy, that's 10 checks potentially. 10 is already greater than 8, dead on arrival. But to add insult to injury, let's go further. This would be checking if the numbers are even. That's 7 numbers checking even. 7 plus 10 is 17. And then, of course, we're going to double the values for even numbers. 17 plus 4, 21. So I want you to pay 21 units rather than 8 units. Anybody interested in doing that? Not at all, right? So that wouldn't fly at all. But what is the consequence of using this code? Well, before I answer that code, let me just do a little bit of refactoring so I can get to that point much more easily. So Boolean is greater than 3. I'm going to say number. In this case, of course, I'm going to return number is greater than 3. I'm going to write this code just a couple of times with different values, is even, and of course I'm going to say mod 2 in this case is equal to 0, and finally let's say int double it, we'll call it as double it, and in this case I will say this is going to return, oh, let's say times 2. Well, I'm going to use these calls up here obviously, so I'm going to change this to sample is greater than 3. You see, we can use the method reference, and I'm going to change this to sample is even, and finally I'm going to change this one to sample, we'll call it double it. Well, now that we have called it all these functions, it's producing still the same result. However, what about the performance of this code? Well, I forgot to mention one thing though, that the streams actually share a characteristics I've actually seen among my children. They both are lazy to the bone. And so as a result, the stream is actually extremely smart. If you go to the stream and say filter, filter, map, it actually doesn't do any of those things. I'll describe a scenario for this that will actually make it really easy to understand, because I've actually seen this happen. My wonderful wife, talks to me, a teenager. She says, I want you to turn off the TV. It's as if no words were spoken, because nothing really happened. And then she would say, I want you to get up and clean up your room, and nothing happens. I want you to finish your homework, nothing happens. And then she will say, I'm calling daddy, and immediately it's like everything happens. So the point really is, all these calls are kind of accumulated lazily, and that I'm calling daddy triggers the execution. Well, that's exactly how Java 8 actually works. So if you go to Java 8 and say, hey stream, filter, it says, yeah, whatever. Filter, map, nothing happens. Find first, oh boy, let me get the work done. So the point is, there are two types of methods in Java 8. These are called intermediate functions, and the last one is called the terminal function. Well, there are two types of functions. Just now the last one is a terminal. There are terminal functions which you normally place at the last. So the point really is, there are intermediate functions that lazily evaluate, and then there are the terminal functions that trigger the evaluation. So the point really in here is the lazy evaluation. So let's understand what that really means. Well, if this was done very naively, you would first take the collection of numbers and create another collection with only numbers greater than 3. Then you would create yet another collection which is even. Then you would create yet another collection which is double, and that would not be very efficient at all. So instead, this behaves very differently. Imagine for a minute these are your 2 feet and you're standing on top of that. Excuse me, you take the number 1 and you drop the number 1, and number 1 says, I'm sorry, I'm not cut out for this, and it leaves, exits right away. So 1 is not greater than 3. We then take 2, and 2 exits, so does 3. We send a value of 5. 5 clears the first filter, but 5 exits through the second door. It says, I'm not even number. Then we take 4. 4 clears the first filter. 4 is, after all, greater than 3. 4 clears the second filter. 4 is an even number. We double the value 4, and then we pass it down to find first, and find first says, hey, thanks, and this shuts down the shop and goes home. So the point really is, we never ever touch value 6, 7, or anything after we reach the result. This is called lazy evaluation. So let's take a look at an example to really see this is actually happening. So if I go up here and say e is greater than 3 plus number, and I'm going to really print that here also for e is even, and I'm going to do the same thing here for double it as well. And now if you notice in this case, when I run this code, you can see that it is actually calling e is greater than 3 for 1, 2, 3, 5, and then it calls e is even for 5. Then it calls the functions for 4, and the minute it hits the bottom for 4, it says, I'm done, and it doesn't evaluate the values for values later than 6. So in other words, it doesn't go through a list after list after list. Instead, it takes a one value, runs through the functions vertically, and only if needed, takes the next value. So the execution order is very different in the computation. It's not what you look at that matters. It's what you see behind this code that the execution really sequence is. So it's a very different sequence of execution. The word lazy really means efficiency. So when you say the word lazy, you have to pronounce it a little differently in Java 8. You pronounce it as efficient because that's what it really gives you, an efficiency in this code. So this gives you an idea about how this efficiency works. So these functions are evaluated as a combined function. This is called a fusion operation. So rather than seeing these as 3 separate lines, fuse them into one line. That one line, a combined operation, is done for every element. So it operates on one first, only then if needed on the second and the third and the fourth, and keeps going lazily rather than having to create a list after list after list, and that brings in efficiency quite a bit. But this brings up the question, how does this laziness actually pan out? Well, let's take a look at this one more time. And for understanding this, I'm going to go back here to the end, and I'm going to put the word done here, but I'm going to remove the very last call from here. I'm going to remove the output from here for a minute. So notice in this case, I have done up to the find first, and I'm stopping at the end of the find first, as you can see. So in this example, as you can see, we are using the terminal operation at the very end of this code. So when I run this code, you can see all that output followed by the done, as you would expect. However, I'm going to stop one step before the find first. And what did I just do? I did all the lazy functions, but I never called the terminal function. So what does the code do at this point? Well, you probably know how this code works because you've seen some people at work like this. They come to work in the morning and they look around and they say, hey, where's the boss? You say the boss is sick today. It's like, yes, I don't have to do any work today, right? So this code is exactly like that. So if you notice in this case, when I run this code, it simply said done and did not do any work at all, as you can see, because all those evaluations are lazy. It says, I'm so glad I did not waste my time doing any of those, and because the result was never requested. So that is a lazy evaluation baked in. So the real power in Java is not just the fact that we have lambda expressions, but the fact that we can actually use it for greater good. That's where we're really getting the benefit out of it. So we can use lazy evaluation, which is baked in, and we can do pretty nice things with it. So this also brings up the question, so if I were to put a breakpoint within the is greater than function, will it be called at all in this sequence of code? And the answer is no, it will not be called because it's a lazy evaluation. So if somebody comes to you and says, before Java 8, if somebody comes to you and says, is it really hard to debug Java code? You probably innocently will say, oh no, it's not hard to debug Java code. Put a breakpoint and happily step through. And they tell you, I'm so glad you're saying this because I've got 700 threads running, and you're going to say, get out of here, right? So the point really is, whether debugging is easy or not depends on the context of what we do, not the code structure. That's exactly the problem here too. Lambdas don't make debugging hard. It is the fact that it's lazy evaluation makes debugging really difficult. Again, not because it's difficult, it's because something we are unfamiliar with. So when you look at the code, you got to ask if wear a pair of glasses and say, when will this code actually run? So the place where you have the code is not necessarily the place where the code would run. You may actually have the code defined here, called here, but it may actually execute at a trigger point elsewhere. That's what makes debugging a little bit more challenging for us until we get used to these things. But once we get used to it, debugging is not, after all, that hard. After all, debugging requires understanding the semantics of the language as well. That's the challenge we have to go through. So I hope that answers the question. So that's basically the issue that we have to deal with. So we saw the beauty and the benefit of the lazy evaluation. Yes, please. Yes. The question is, what is the value that we are getting back? Absolutely. So the result of this evaluation that you see right here, let's actually do this. I'm glad you were asking the question. So stream, let's say this is going to be integer after all, and I'm going to say stream is equal to, and I'm storing the stream right here off the bat. So obviously in this case I need the stream, so let's bring that in. So I'm going to say this is the stream.stream. So you can see in this case I've taken the result and stored it into stream. However, notice what I'm going to do now. I'm going to say stream dot, take the stream that we stored away in, and I'm going to call find first now, and I'm going to call done and then find first, and you can see that in this case the done came first and the evaluation came next. It is that lazy. It's, waits until you really call it, right? So this is like me trying to file the tax return, right? Every April 15th at 11 p.m., I have a conversation with the Lord. I say, dear Lord, if I'm going to live for another hour, let me know now so I can file the stupid tax return, right? So that's basically how this works as well. So thanks for asking that. You're basically storing that away and then calling that right here. So that's exactly what's happening. So we saw the laziness. So let's revisit the benefits we saw of these things. Well, the very first benefit is we got code clarity on our hand. Let's take a look at an example of code clarity for a second here. The code I wrote previously was an imperative style of code, whereas this code here you can see is a functional style of code. But what's the biggest difference between the two? Well, the very first difference is when you looked at the code in the first place where we did the looping, you have to go through the loop to try to figure out what in the world the code actually is doing. And that can take quite a bit of effort and time, as we talked about earlier, and that's going to take a little bit of explanation to do as well. So the point really is, we've been doing imperative style code for a very long time, and we can say result equal to 0, and then output the result, and then of course we could walk through element is going to be in numbers. But here is the beauty, right? This is something we have all done several times, and as a result, to you and me, this is something we are very comfortable and familiar with, but it still requires quite a bit of ceremony. So in this case, result is equal to e times 2, and then you break out of it. But every time you look at this, you got to examine the code and understand what it's doing. But on the other hand, if you look at the code in the bottom, it is a lot more expressive than the code in the top, as you can see, because it follows through very naturally. But here is the question. If you look at the code in the top, if I tell you that I want to change a condition, what would you have to do? You got to step right in between this, and you got to make change to this. And usually that's very unnerving, because you make a change usually, and then you stare at it for a little bit, and you ask yourselves, is this good? On the other hand, if you look at the code in the bottom, notice what's going to happen. You got all these lines stacked up. You don't want a condition. You remove a few lines. You want a few more conditions. You insert a few lines. It becomes a lot easier to work with the code. So this is a lot more expressive. Yes, please. That's right. So the question is, can you write your own terminal? The short answer is no. The long answer is don't go there. And so the short answer to that is, you can actually do this fairly effectively with functions like reduce and stuff like that. So you can come close to it by providing a lambda, then creating our own. If you're going to create your own, that's a way too much effort. Instead, you can just work through the reduce functions much more easily. So I would rather do that. Now, here is the beauty about this expressiveness, as you can see right here. If you look at the code in the top, I said that this takes a little bit of time. Imagine you are sitting down coding, and next to you is your wonderful business analyst. And your business analyst asks you, hey, what does this code do? Your response normally is, that's what I'm trying to figure out, be quiet. On the other hand, if you look at the code in the bottom, you can actually have a conversation with them. Given the collection of numbers, I'm going to check if they are greater than 3, get all the even numbers, double it, and get the first one. What do you think? And the person can actually, talk to you. So this is a better code. It's more expressive, as you can see. That becomes a lot easier to work with. Well, we saw how expressive this code really is, but we saw the clarity this code gives also, so that's all really nice. But what can we do with these kinds of facilities on our hand? Well, let's talk about this real quick, about some of the things we can benefit from. First is the code is clearer than it was before. We're going to have fewer errors. Why are we going to have fewer errors? We are not dealing with mutability as much. That reduces errors. The code is easier to understand, easier to explain, easier to work with, easier to modify. All those things end up reducing errors as well, so there is quite a bit of benefit for that. But this also leads to yet another benefit, which is it's easier to parallelize as well. But to understand this, let's put this into a context of something else that we can actually look at and how we can benefit from that. So let's talk about one other example I want to write here so we can get a feel for how that would work. So I'm going to start out with a list of tickers, and I'm going to say tickers.symbols as some symbols I have gathered up here into tickers. So I got some ticker symbols on my hand. I want to make sure I'm connected to the network here. I'm going to use that, so I'll get back to that in a second. We will see how we can get the symbols and tickers and work through that. Well, I have to get the internet connection, but I'll do that in a second. So how do I really write the code to get the prices and work with it? Let's say I got these ticker symbols. What I want to do really is I want to get all the price values, and then once I get the price values, I want only the ticker symbols. Ticker symbol, that's the first one in the order given, greater than $500. So less than $500. So the highest price, less than 500. So how do I get the highest price, less than 500? I'm going to write this code in imperative style first, then we will write it in functional style, compare and contrast, and see where we are going with this. So I'm going to say timeIt.code, and I'm going to call a little function called findImperative, and I'm going to pass to it tickers.symbols first. And let's go ahead and write the function find imperative. This takes a list of string symbols to begin with. This function is not doing anything. It shouldn't take time to do anything. So it's a -4. That's great. But what am I going to do within this particular function? Well, within this function, what I'm going to do is I'm going to ask it to provide me the values that we for these ticker symbols and get the values. Let's try it. So first of all, I'm going to say list of stock info. Let's see what stock info is. Stock info is just a POJO. It contains a ticker name and a price, and you can see the price and symbols, nothing really big. So I'm going to say stocks equal to, and I'm going to say new array list of stocks. Well, now that I have the array list, what am I going to do? I'm going to simply say for, well, string a symbol that comes from the symbols, obviously. And then I'm going to say, in this case, well, stocks.add. So I'm going to add stock info, and this is going to come from stockutil.getPrice, and I'm going to say symbol and ask him to get the price of the symbol. Well, if you take a look at the stockutil, let's go ahead and look at what it does. Well, the stockutil has a function called getPrice, which is going to return a stock info after getting the price from the Yahoo Finance web service. Great. Now that I have all the stock symbols, what's my next step? I'm going to create a list of stock info. In this case, I'll say stocks less than 500 equals to new. This is also going to be an array list, obviously. And then I'm going to say for stock info. And this is going to be a stock coming from stocks, obviously, in this case. And what do I want to do with the stocks after all? Well, I'm going to ask it if stockutil is price, let's say, less than 500. Well, is price less than 500 returns a predicate. A predicate is a functional interface like consumer we saw earlier. It has a test function we can actually call into. So I'm going to say dot test the stock. If it is happy with it, I want to say stocks less than 500 dot add and add the stock to it. As a very last step, what I'm going to do here is I'm going to say here is a static variable called stock info. We'll call it dummy equals new stock info. And this one is going to be just a 0.0. And I'm going to say here is a stock info. We will call it high priced. We will set this value to dummy to begin with. Then we say a stock info and go through the loop of stocks less than 500. And this time, though, I'm going to say high priced is equal to stockutil. We'll call a pick high among stock high priced and the stock itself. If you look at pick high, it takes two stock info but returns the one with the highest stock price. That's basically what this is doing. Well, given this, the very last step here, of course, is to output the high priced. Let's go ahead and run this code and see what output it provides. Now, clearly, you wouldn't write the code in imperative style like this. I wrote 3 loops, but nobody would write 3 loops. You would merge all of that into one heck of a loop. But of course, if you write one loop, nobody can understand it, but who cares about learning and reading the code? We only care about writing code after all. Well, here is the response it gave us, and you can see the result. It took about 13 seconds, and the price was $143 for IBM stock price. Let's try this one more time again, though. But this time, though, I'm going to write this as find a functional instead of imperative. And I need your help to write this. So public static void find functional. But I'm going to take something a little different in this particular code, though. I'm going to pass to it a dot stream after all, rather than passing a collection of strings. I already have a stream up here, so I'm going to say this is a stream of string, and I'm going to call this as symbols. And now that I have all the symbols on my hand, what am I going to do? I'm going to output, of course, but this time I'm going to say symbols dot. Well, help me out here. I've got the stock symbols, but I want the collection of stock prices. What kind of function could I use to perform that transformation? A map. Awesome. You guys are listening. That's great. So I got a map function, stockutil, and I'm going to say get price after all. But you see, I don't want all the stocks. I only want those less than 500. A filter, I heard. Great. And this is going to be stockutil is price less than 500. Remember, it was returning a predicate. Filter wants predicate. That's awesome. And the final thing I'm going to use here is a function. Well, let's actually see what this is. I'll give you a little clue. Salt is to pepper as map is to, I like this game, reduce. That's correct. So reduce, and I'm going to start with the dummy, and then I'm going to say stock util pick high. So this gives us the price for us. In reality, this is a functional style of code we wrote. I'm going to run this code, but while we run this code, let's talk about what we just did. We wrote that imperative code in the top, as you can see, that took quite a while to write. But this one says, given a collection of symbols, transform to prices, get me the ticker symbols, and then give me the high price. Would you agree the time is about the same, give or take, right? So 3 seconds, the internet speed, not big deal at all. Is price the same? I'm really sorry, apologize. Just because you write functional code, you don't get better stock prices, right? So absolutely the same price as well. Time is about the same too. However, looking at this, we wrote a lot less code. So which one would you write? The imperative code or the functional code? The imperative code, of course, if you're a consultant getting paid by the number of lines of code and the hours you work, right? If you care to get your work done and go home, obviously, this is a better code. Well, great. But having said this, is there any other benefit? Let's enter into this thought for a minute. Let's say you had the functional code on your hand, and you wrote this functional code, and what does it do? It does everything sequentially. Remember the last project you were on where you had all this code, sequential code at work. Remember the day you came to work and everybody actually smiled at each other. That was a great job until one day they told you, we got to improve performance. And as a result, what did you do? You decided to use multi-threading. And what happened when you used multi-threading on your project? The code that was so nice to work with suddenly turned into a monster, right? And it had threads everywhere and locks everywhere, and you could never recognize this code anymore. But then something else happened as well. In addition to turning into a monster, what did this code do? It started giving you errors every corner. You had to spend your days and nights debugging. Remember that project? And after a while, you've had it. And one late night, while you were debugging, you realized how miserable life has become. And while in the middle of the debugging session, you applied for this other job. That's called concurrency, right? So you're like, oh my goodness, I don't want that anymore. Why would I want to do this kind of job after all? Well, sure, we all been bitten by this over time, so we all hate doing it several times over. But notice that though, we use functional style. We did not mutate any variables explicitly. We wrote pure functions, and writing pure functions, we wrote concise code. So you can see about in the ballpark of 10 plus seconds over and over, but somebody comes to you and says, we got to make this really faster, we got to make this parallel. Well, sure, I can make this parallel. All I'm going to do is simply say parallel stream. And so I did not change the code structure. I simply made one small change to this code. That's all I did. But for doing that, what we got back was exactly the same result, but with a lot less time, because of course we were able to unleash several threads on it at one point without having to change a lot of code. So you can see how wonderfully easy it is not only to write the code and enjoy lazy evaluation, but to get real fairly good performance as well. Where it makes sense to use these kinds of threads, we can employ these threads as well. Of course, that's not to say we want to take everything and make it concurrent. There are certain problems where concurrency makes sense, and there are problems where it doesn't make sense, so we still have to use our judgment, and that's why they didn't make everything concurrent. I call this the master switch. It's a switch they have given you, and you have the responsibility to know whether to flip it or not, and flip it when you shouldn't, you hurt yourselves. But on the other hand, if you flip it when it makes sense, you can get a fairly good performance with it as well, and that's one of the benefits you get out of it. So to summarize what we talked about, we can see the benefits you got out of this approach, which is you are writing a lot less code. The code is a lot more concise. The code is easier to understand, easier to work with, easier to maintain. You're able to enjoy the lazy evaluation, and you're also able to parallelize it where it makes sense. Well, in addition to all of this, it actually makes sense to explain the behavior of the code. And it also becomes a joy to write code finally in Java. And that is one of the things that really excites me. For a long time, I did not really get excited about writing code in Java, but this kind of code actually brings back functional style of programming into Java, and as a result, it's a lot more pleasure to work with as well. I sincerely hope you found this useful. Thank you.
files for the top. And my explicit modules are exactly. So the mix is the module path where mlib is the explicit modules, lib is the jar files.
Lib is the automatics.
The automatics. That is correct.
That is correct.
That is correct. You've got no other comments for one, so I don't know what it is.
Yes, Francis, Eric, Sutton is here. See him there, yeah. In the check shirt with the orange folder. It's time to see what I'm thinking people will.
Pull up the slide. Yeah. Pull up the slide, Alan.
Sorry, go back to this one again. No, I was not a trick sheet. mlib is correct. The explicit modules are in the mlib directory. The original jar files were in the lib directory. So to run it, yes, that should be mlib lib. That is correct.
I was thinking actually the class file is all its mods, and then you jar them, and jars is the big
Oh, did you say the wrong thing?
I said the wrong thing.
But the slide was correct.
Everyone was watching the slides.
Okay.
But you confused at least one person.
He was confused. I was worrying because you said it was yeah, not because my lib, mlib, mods. The whole thing is it needs a bit of background. I would be diagrams.
Oh,
Just like the little images. Yeah, first goes here, and then goes across.
did they let? So I'm taking a picture of someone in the audience taking a picture of me. And you're taking a picture of that. So you should be taking a picture of him. Right, then we'll have a full cycle. Okay, I think we can start. I think everyone who's coming is here. So welcome everyone. This is Project Jigsaw Under the Hood. My name is Alex Buckley. And before we get started, I know people have been doing polls all day. I will always like to ask a captive audience such as this, who is running JDK 8 in production? Right answer. Who is running JDK 7 in production? It's all the same people. Who is running JDK 6 in production? Good, good. 5? At the back, yes, okay. 1.4? Okay, so mark this day. No one is running 1.4 in 2015. 1.3? 1.2? 1, right, okay, good. Has anyone tried any JDK 9 early access builds? Some, okay. The JDK 9 EA with Jigsaw? Fewer, okay, because they're two different binaries. Who attended Prepare for JDK 9 this morning? Lots. Intro to modular development? Some advanced modular development, different, actually more than intro, okay. Who plans to attend the Jigsaw hack session tomorrow morning? Some, all hands up, good, good. Okay. Thank you for that. Let's recap. Obviously, many of you will have seen lots of this stuff at something of a different level, and I'm going to go through it today. So bear with me. Let's just recap with a quick survey of the modularity landscape. First, the Java Platform Module System. This is technology being defined in the JCP for Java SE9. The expert group started discussion in February 2015, JSR 376. Second, the Java SE9 platform itself will be defined in the JCP, though no JSR has been filed yet. And that JSR will own the modularization of the Java SE API, that is, the allocation of Java SE packages like Java Lang and Java SQL into modules. Third, Project Jigsaw is an open JDK project to implement the Java Platform Module System in JDK 9. That's JEP 261. It includes support for modules in Java C, Java Doc, the Java Launcher, and other JDK tools. Project Jigsaw also splits the JDK into modules. There are 3 JEPs for that, 200, 201, 260. Those modules will be an input to the Java SE9 platform JSR when it modularizes the Java SE API formally. Project Jigsaw also replaces rt.jar and tools.jar with a new runtime image and directory layout. That's JEP 220. This will help modularity in the long term, but it's not directly related to the module system. It's an implementation change specific to the JDK. With all these JSRs and JEPs, you might be wondering what this talk is about. When you use JDK 9 and the features implemented through Project Jigsaw, you're subject to the rules of the Java Platform Module System from JSR 376. That's what's under the hood. So really, this talk is less about Project Jigsaw and more about the Java Platform Module System. The talk has 3 parts. The first part explains how the module system works with the language and VM to offer certain guarantees. The second part is about migrating to modules. And the third part is really under the hood, what the module system is fundamentally capable of beyond what you can express in the Java language. I want to set some expectations for this talk. The style is quite different than the style of a talk about, say, lambdas. Lambdas are about the shape of programs in the small, individual for loops turning into method calls with lambda arguments. You can reshape a program to use lambdas without anyone noticing. Modules are about the shape of programs in the large. We deal with classes and packages and get bigger from there. If you reshape a module, it's quite likely that other people will notice. So this talk is less about the code you can write for yourself and more about the kind of system that you can set up. Also, 1 second. Lost my pointer. 1 second. There we go, my pointer's back. Because modules affect all phases of development, compiling, testing, packaging, deploying, running, they're much more connected to the tools ecosystem than a feature like Lambdas, which only needs IDE support. Tools like Maven, Gradle, Ant, and so on don't support modules yet, but that's okay, the JSR is still in progress. Everything will be all right in the end, so if it's not all right, it is not yet the end. Accessibility and readability. Everyone knows the hierarchy of accessibility in the Java language and VM. It's simple to understand, easy to use, and strongly enforced by the compiler and VM. But it has a big weakness. The only way to share code between packages is with public, but then you're sharing with everyone. It's not surprising that package friendship in one form or another has been requested many times over the years. One goal of the module system is strong encapsulation to allow a component to declare which of its public types are accessible to other components and which are not. The lines in italic are the levels of accessibility connected with the module system. So reading upwards, you can arrange for types to be accessible only within their modules, or accessible within their module and to other specific modules, or accessible to everyone. Now, as usual, migration drives a lot of our thinking. We want to make it easy to place an existing package into a module and immediately give that package the benefit of strong encapsulation. We don't want each and every public type in a package to have to opt in to strong encapsulation. So, public types in a package are not accessible outside the module by default. That is, public on a type declaration no longer means that it's always the case that everyone can access the type. What happens if someone tries to access a public type that's not accessible? Here's an example from Glassfish 4.1. Glassfish 4.1 doesn't start on JDK 9 because the VM throws an illegal access error. There it is. You probably can't read the error message. The error message is class ComSun Enterprise Security Provider Policy Wrapper in module unnamed module, don't worry about that yet, cannot access class Sun Security Provider Policy file in module Java base. The point is that the class Sun Security Provider Policy file is declared public within the OpenJDK source code. But since it's a JDK internal API, it's now accessible only within the Java base module. Sorry, Glassfish, or outside the Java base module, you need to find an alternative to this internal API, as the title of the bug kind of admits they know. So in Java SE9, modules are first-class program components like classes and interfaces. here's a declaration of the Java SQL module that contains JDBC. It's in a file called module.info.java in a directory named after the module. The compiler treats it like any other Java file and translates it to module.info.class, which you can put in a jar as normal. We call that a modular jar. Lots of you have seen that earlier today. The package hierarchy exists in the same directory, source Java SQL, as module.info.java. So module.info.java is outside all of the packages of the module. It's, in fact, the job of this module declaration to say whether a package is strongly encapsulated or not. It's easy to get strong encapsulation. Don't mention the package in the module declaration. To allow other modules to access the package, or more specifically to access the public types of the package, add an exports clause. You can export to all other modules, or you can say exports to give access to only your friend modules. At compile time, Java-C prevents code outside the Java SQL module from accessing any packages except for those listed as exported. You get the same compile time error as when you try to access a package private type from outside the package in JDK 8, and in fact, since forever, right? At runtime, the VM throws an illegal access error like you saw with Glassfish. Let's look at the VM more closely. Traditionally, accessibility in the Java platform is about who is doing the access and what is the public protected private flag on the target class. At runtime, the VM uses the class loader of the accessing class to find and load the target class, and then the VM checks the flag on the target class. Because the VM relies on class loaders, people can create loaders that only know how to find and load classes of certain packages. In effect, loaders can isolate one package from another. In the top picture, class p.c is trying to access class q.d. I have very exciting class names, as you can tell. The loader for class p.c knows how to delegate to another loader for any class in package q, such as q.d. Only when that other loader has loaded q.d can the VM check its flags to determine if p.c can access it, for example, q.d being public in the past. In the bottom picture, the loader for p.c has no idea where to find package q, so no access to q.d is possible from p.c. Technically, this isn't a failure of accessibility because the VM never gets to check the flags of q.d because q.d isn't loaded. Instead, it's a failure of visibility. q.d is invisible to p.c. Still, the effect is quite powerful. If the class loader of the accessing class can't find and load the target class, then it doesn't matter if the target class is public. It's effectively encapsulated. Whoever sets up the class loaders sets up the encapsulation. But encapsulation based on class loaders, like in the bottom, isn't strong encapsulation. It relies on packages being carefully apportioned into different loaders, but that isn't how the JDK works. Most code in the JDK is loaded by the bootstrap loader, while code on the class path is loaded by the application loader. Spinning up lots of loaders for all of this code would be a compatibility nightmare. In any case, in this bottom picture, there is no actual isolation. You can circumvent class loaders by getting hold of references to Java-lang class objects. Once you have a class object, class loaders are irrelevant. You can do anything with them. And it's impossible to stop references to class objects from being passed around a program. They're just references to class objects. Strong encapsulation is about being able to prevent access, even if the accessing class and the target class are in the same class loader, and even if someone is using core reflection to manipulate class objects. Let's assume that different modules, X and Y, are somehow, we'll come to that later, mapped to the same class loader. Can class P.C in module X access class Q.D in module Y? Another goal of the module system is reliable dependencies, to replace the brittle error-prone class path mechanism with a means for program components to declare explicit dependencies upon one another. So, in order for P.C to access Q.D, not only does module Y need to export package Q, but module X needs to explicitly depend on module Y. The formal name for depends on is readability. Readability, that reads edge, we'll be seeing a lot of them, underpins accessibility in the Java language and VM in SE9. The accessing class P.C must be in a module that reads the module of the target class, that reads Y, and that module containing the target class, module Y, must export its package Q to at least, maybe to more, but to at least the module of the accessing class, module X. So you can see that accessibility is a two-way street. X reads Y, and Y exports package Q to X, and probably many others. This accessibility is independent of class loaders, just like accessibility was before the module system. This is important for two reasons. First, it means accessibility works at compile time when there aren't any class loaders. Second, it means you can reason about accessibility based solely on requires and exports clauses in module.info.java. There's no need to worry about this class loader mapping and the class loaders in existence at runtime. In fact, accessibility is actually quite straightforward. A package is either exported or it isn't. But on readability, there's actually more to say. When you depend on a module, you depend on a hopefully coherent collection of packages that it exports. In some sense, those packages are the interface of the module. Inside the module, hundreds more packages may sit, encapsulated, waiting to help implement the interface. And more than that, when you depend on a module, you implicitly depend on all the modules it depends on. For example, if you depend on the Java activation module in JDK9 with its 35 classes, then you implicitly depend on the Java desktop module with its 5,583 classes. If the watchword for JDK8 was functional, then for JDK9, it's transitive. You should think in terms of the transitive set of modules needed by your application. The indirect dependencies can be as important as the direct dependencies. Let's see how readability handles this. I'll use an example of readability, a real example from the graph of Java SE modules. The Java SQL module that holds JDBC on the left requires the Java logging module that exports the package Java util logging. This lets code in the Java SQL module, on the left, in the blue, access the public types of Java util logging, such as logger. You can see some code in the JDBC driver manager class is newing an instance of logger as an anonymous class. Good. What if the API of the Java SQL module, rather than its method bodies, wants to use the logger type? For example, the JDBC driver interface wants to return a logger. So logger's right there in a public method signature. Let's look at this through the eyes of an application module that uses JDBC, myapp on top. In order to use the driver method that returns a logger, the myapp module not only needs to read the Java SQL module, but also the Java logging module that exports the logger type. It will be a pain if the developer of myapp had to remember to say requires Java logging, sad face, when using the API of Java SQL that's going to return a logger. There's good news. The Java SQL module can take on the responsibility of remembering. Look at the Java SQL module. The Java SQL module now says requires public Java logging. The word public here means that anyone who reads the Java SQL module also reads the Java logging module for free. The MyApp module no longer has to bother with requires Java logging, cross out, happy face, because the MyApp module reads Java logging thanks to reading Java SQL. This is called implied readability, and it's very powerful. It's powerful because it lets a module be refactored without breaking consumers. For example, suppose that JDBC has a Java SQL time package that we'd like to ship in a separate module. This new module, Java SQL time, same name as the exported package, is at the bottom right. The Java SQL module can say requires public Java SQL time so that MyApp, which explicitly reads Java SQL, implicitly reads Java SQL time, the Java SQL time module. And it goes further. We could refactor the Java SQL time module by extracting a Java SQL date module. The Java SQL time module would say requires public Java SQL date. So anyone who reads Java SQL time also reads Java SQL date for free. MyApp at the top would be unaware that this is happening, that this refactoring is happening. In essence, the readability model supports downward decomposition. Any module you read can be decomposed into new modules, and readability of those new modules can be recovered with a requires public clause in the old module. You can see here that the definition of reads is recursive. A module X reads another module Y by requiring directly at the top, or by reading some third module Q, there's the recursion, where Q says requires public Y. And now that X reads Y along the bottom, Y can say requires public Z, something else, and X will read Z as well. Now be careful. Once people require your module explicitly by name, you can refactor it as much as you like, but you can't delete it. There's no way for a module to stand in for another module by taking its name as an alias. If someone requires X and X is deleted, the module system won't start. Someone's broken a contract, effectively. Everything so far has been about accessibility in the Java language and VM, where the accessing class P.C and the target class Q.D were known statically. But accessibility extends to dynamic class references that you manipulate with the core reflection API, that is JavaLang Reflect. In this code, C, the method parameter, is a reference to some class object. The reference is dynamic. We can't control which object is referred to by C at runtime. Maybe it's a class object representing a private class of an unexported package of an unreadable module. That is, a class object representing what would clearly be an inaccessible class. Similarly, we can't control what the array MS refers to. Maybe private methods of this inaccessible class. Now, we want to preserve strong encapsulation even when core reflection is used to access types and their members. The only opportunity to do this is when an operation is performed on a JavaLang Reflect method or a JavaLang Reflect field. Operations like invoke and get and set for field on these classes perform the same pair of checks as the compiler and VM. Does the caller module read the target module? And does the target module export the relevant package to the caller module? Even set accessible respects strong encapsulation. Suppose you have a JavaLang Reflect field object representing a private field of a public class. Public, is it accessible? Well, the public class is in a package that's not exported by its module. Set accessible on that field will fail. It can't manipulate the accessibility of anything in a non-exported package. Just like get and set methods on a Java lang reflect field, setAccessible performs the same pair of checks as the compiler and VM, and I'm going to say them again because it's the same rules all the time. Does the caller module that's calling setAccessible read the target module, and does the target module export the relevant package to the caller module, whoever's calling setAccessible? If all that checks out, then the private field can be made accessible via setAccessible true. So that's accessibility and readability. Accessibility used to be a simple check for public or same package. I'm skipping protected because it's a whole den of iniquity in itself. No one wants to go there. In Java SE9, accessibility strongly encapsulates module internals. Accessibility relies on readability. You have to have that reads edge, which can be direct or implied. And the key point really is accessibility is enforced by the compiler, VM, and core reflection. Let's take questions at the end. Let's do some different kinds of modules. Everything so far has been about named modules. Modules explicitly declared with a name in moduleinfo.java. Got a bunch on the left. What about jar files on the class path that don't have a moduleinfo.class file? They seem to be in this world of their own. To keep the model of accessibility and readability consistent, we introduced the unnamed module. All classes not in named modules are in the unnamed module. It is as if everything on the class path is in one big module. Because it's a module, we can ask two questions. What does it read and what does it export? What the unnamed module reads is simple. Every named module, all of them, as if by magic, for free. This means anything exported by a named module can be accessed by the unnamed module. You can turn a jar file into a named module by adding moduleinfo.class, put the jar on the module path where modules are found, and the jars left on the class path, in red, in the unnamed module, won't realize anything's happened because they can read your named module. That's a huge help for migration. The next question is about what the unnamed module exports. Before that, though, we should ask, the unnamed module reads all these named modules. Who reads the unnamed module? Was anyone thinking that? Who reads the unnamed module? Just wondering. Some people. Remember, our goal in the module system is reliable dependencies. We believe very strongly that named modules should not read the unnamed module out of the box. It would make a mockery of reliable dependencies to have modules, named modules, depend on the arbitrary content of the class path. So, you can't write requires unnamed or requires class path in a module declaration. There are no reads edges going out to the unnamed module. This looks like a huge hindrance for migration because any jar you turn into a named module can't access the jars, can't read, and thus can't access the jars left on the class path. The answer is automatic modules. You can take a jar, say guava.jar, and move it from the class path to the module path. This turns the jar into an automatic module. That's all you have to do. You move the file. An automatic module is a named module, declared implicitly rather than explicitly. Its name is derived from the jar file names, from the jar file name in obvious ways. Placing guava.jar on the module path gives an automatic module, an automatic named module called guava. As before, whenever you see a module, you should ask, what does it read and what does it export? The automatic module Guava reads everything in the JDK image and the unnamed module. It's as if it says requires unnamed. Now the hindrance to migration is gone. You can turn a jar into an automatic module by moving it, and it can read the unnamed module and thus access the jars left on the class path. We asked earlier what the unnamed module exports. Now the answer, we're ready to give the answer. The unnamed module exports all its packages, all the packages in junit.jar and glassfish.jar and hibernate.jar, precisely to help code in automatic modules, which, like Guava, read the unnamed module. Because an automatic module is a real named module, as if you declared it yourself, another named module can require it. Here, the JavaFX core module, which is a real named module, there's a declaration and everything in JDK 9, it says, imagine if it says, requires Guava. That means there's a reads edge from JavaFX core to Guava. What does an automatic module like Guava export? Easy, all its packages. So JavaFX core can access all of the public Guava types. JavaFX core could even say requires public Guava to transmit its dependency on Guava up to its own consumers. So anyone who reads JavaFX core, there's a whole stack of JavaFX stuff above that, will also read Guava for free. So moving a module from the class path to the module path means you get an automatic module that lets you start building up your own graph of modules. It's not necessary to wait for every jar on the class path to be modularized by its author before you start developing modules that require it. By the way, what happens with the second automatic module? Hibernate. Moved from the class path to the module path. Well, automatic modules read each other as well as all modules in the JDK and the unnamed module. Guava reads Hibernate, Hibernate reads Guava. They both read all the modules in the JDK image. They both read the unnamed module. In some sense, they read as much as they did when they were jar files on the class path, sort of morally. So our goal clearly is for you to take groups of jar files from the class path, move them to the module path, require them from your own named modules, and have everything just work. In some sense, automatic modules in the module system are like raw types in generics, necessary evil. Necessary because they enable migration, and evil because they look straightforward on the surface but add a lot of complexity behind the scenes. That's our problem. That said, we've had good experience using popular jars like JUnit and Juice, to take some examples, as automatic modules. You put them on the module path, you can require them, easy. So, there are three kinds of modules. Explicit named modules, like JavaSQL, automatic named modules, like the Guava example, and the unnamed module, aka the class path. And the key point is there is lots of readability between these modules given for free to help migration. The third and final part, loaders and layers. I said before that strong encapsulation is independent of class loading. There are no changes in the JavaLang class loader API due to the module system. Class loading doesn't change. In some sense, the module system exists underneath the VM's class loading architecture, not on top of it. VM at the bottom, module system, class loaders. The module system works with whatever loaders already exist. It doesn't feel the need to create or mandate its own weird and wonderful set of loaders. And so, good news, JDK 9 has the same three loaders as JDK 8, bootstrap, extension, and application, sometimes called system. Some implementation details of those loaders have changed, but that shouldn't matter to ordinary programs. Most modules you've seen, like Java Base and Java SQL and Java Logging, have their classes defined by the bootstrap loader. A few modules, like Java Corba, have their classes defined by the extension loader, and out of the box, a handful of modules related to tools have their classes defined by the application loader, where most modules will end up, actually. It's important for security that Java SE modules be moved out of the bootstrap loader if possible. Modules in the bootstrap loader run with all permissions, which is not ideal from a security perspective. They can only be deprivileged, that is, run with fewer permissions, if they're not in the bootstrap loader. We've spent a lot of time and effort on moving modules out of the bootstrap loader so they can be deprivileged. Frankly, for a module as big as Java Corba, we've moved to extension, 1,833 classes and 31 exported packages, that is no small accomplishment. The deprivileging work itself, figuring out the permissions and setting them on a per module basis, will continue throughout JDK 9 and JDK 10. So while the module system doesn't create loaders itself, it is responsible for associating loaders with modules. If you have any classes in your VM, there has to be a class loader to load them. But the module system will associate those loaders with modules. To help manage this, the module system introduces a concept called a layer. A layer is a family of class loaders that together serve to load classes for a graph of modules. Out of the box, JDK 9 defines the boot layer, consisting of the three familiar loaders. It's the boot layer that associates the Java Base and Java SQL and Java Logging modules with the bootstrap loader, Java Corba with the extension loader, and so on. That's the boot layer. Now, the boot layer is the only layer that most people will ever have to think about, or indeed not think about, but there's a lot more to say about layers. A layer is created from two things. There's a graph of modules that it's going to manage, and a function that maps modules to loaders. On the left, it's the graph from resolving the JDK JLink module, which contains the JLink tool for building runtime JDK images. You can see JLink depends on some internal module and the JDEPS module, and you go down through some compiler modules, and of course you get to Java Base. Also, to create a layer, here's a Lambda expression mapping modules to the bootstrap loader and to the application loader. Very simple example. Base and logging go in bootstrap, everything else, JDK compiler, blah, 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 go in the application loader. Creating a layer with those two bits of information informs the module system about the classes that will exist in the program and the modules they'll come from. The module system passes this information to the VM, so that when classes are eventually loaded, the VM knows which module a class belongs to and what that module reads and exports. Layers mean that the VM effectively has a shadow copy of the module graph that it uses when checking accessibility between classes, and it needs to know about readability. So the VM knows about all of those reads edges. Now, because of fundamental constraints in how class loading works, the module system must enforce certain constraints both on the module graph that I showed and on the mapping from modules to loaders. Let's talk about constraints on the graph first. This is the graph of Java SE modules today. What do you notice about it? My question to you, is there anything that you notice about this graph? Sorry? Apart from the dots and lines. Sorry. What, sorry? Ah, yes. So what was it? Yes, it is a directed acyclic graph that has no loops, because that's the same thing. There are no cycles in this graph. This is fundamental in the Java platform module system. Cycles bring an entirely new dimension of complexity. It has taken over half a decade to detangle the tens of thousands of classes in the JDK to the acyclic and relatively sane state that you see here. We don't wish that pain on anyone else. Java Application Architecture is the best book about modularity I have ever read. In a section titled Cyclic Dependencies, the Death Knell, it says excessive dependencies are bad, but cyclic dependencies are especially bad. The book goes on to say, generally speaking, cycles are always bad. However, some cycles are worse than others. But remember, this book was written years ago, before the module system came along. Cycles among classes are tolerable, assuming they don't cause cycles among the packages or modules containing them. Cycles among packages may also be tolerable, assuming they don't cause cycles among the modules containing them. Module relationships must never be cyclic. So that's clear enough. Module graphs must be acyclic. Let's turn to another requirement on module graphs. The requirement is that a module may read at most one module that exports a package called P. If a module could read more than one module that exports P, as X appears to be trying to do by requiring Y and Z, in which module would P be accessed? There is no answer. The system would just be broken. So we defend against that. Only module graphs which obey this constraint and have no cycles can be turned into a layer. Let's turn to the constraint on the mapping from modules to loaders. Remember the mapping, modules to loaders, is an essential part of a layer along with the module graph. There's only one constraint. It's due to a fundamental limit in class loading. A class loader can only create one class called C. If multiple modules in the graph have a class called C, then those modules must be mapped to different loaders. More broadly, we say that if multiple modules have the same package, then whether or not they export it, just for simplicity's sake, those modules must be mapped to different loaders. There's a secondary constraint on this mapping that I'll talk about, though it's not practical to check because it concerns how the loaders behave at runtime. By the way, quick poll. Who's ever written a class loader here? Wow, that's a lot. So you all know about class loader delegation. Excellent. The secondary constraint, hinted at the bottom, is that loaders must delegate to each other in accordance with the reads edges of the module graph. That is, loader delegation must respect module readability. The reason is obvious. If module X reads module Y, then in order for X's classes in one loader to access Y's classes in another loader, X's loader must delegate to Y's loader. Now, there are no read cycles in the module graph, right? So you might expect that there would never be delegation cycles between loaders, regardless of how the modules are mapped to loaders. Unfortunately, this is not the case. You can get delegation cycles if the map from modules to loaders is bad. I'll illustrate bad with an example, quite an interesting example from the JDK. In JDK 8, the 4 org.w3c DOM packages you see here were present in arty.jar and defined by the application class loader. But it turned out that JAX-P, the JCP technology which endorses W3C technologies, never actually endorsed these 4 packages. Their presence in the JDK was unofficial. What should we do with them in JDK 9? It turns out that JAX-P doesn't want to endorse them. So the obvious answer is delete them. However, XML libraries outside the JDK assumed these packages are always present in the application class loader. So rather than making every library ship its own copy, we decided to ship them in their own module, JDK XML DOM. You get this module if you require JDK rather than requiring Java SE from your own code. In the JDK module graph, there's JDK XML DOM sort of hiding out near the bottom. In the boot layer, we planned to map JDK XML DOM to the extension loader because it has no need to be in the bootstrap loader. It's not some security-sensitive VM-friendly system thing. And this looks good. JDK XML DOM requires Java XML, so there's a reads edge, and the extension loader will delegate to the bootstrap loader for types exported by Java XML. Great, this looks great. Unfortunately, someone added a JDK plugin module, top right, that required JDK XML DOM, and they mapped that JDK plugin module to the bootstrap loader. So there are no cycles in the reads edges, right? But for class loading to work at all, there would have to be a cycle in the delegates edges. That's bad. Sooner or later, a delegation cycle would become an infinite loop. Class loading is very unpredictable. But set that aside and consider this. The bootstrap loader, as a matter of fact, never delegates. So in fact, the mapping of modules to loaders in this case for that plugin module is just wrong, given that reads edge from JDK plugin to JDK XML DOM. Now, fortunately, we caught this in time. One possible fix was to rewrite JDK plugin to not depend on these DOM packages, so that green reads edge to JDK XML DOM would go away. Now, this fix might sound unlikely, but it's surprisingly common to clean up parts of the JDK and discover you can cut out many dependencies. Another possible fix was to move JDK XML DOM up to the bootstrap loader. That's not great. The solution we actually chose was to move JDK plugin down to the extension loader. It's not trivial, but that kind of deprivileging is always the right answer long term. So, going back to loaders respecting readability. There should be no delegation cycles between loaders, just like there are no read cycles in the module graph. And another aspect of loaders respecting readability concerns split packages. Who knows about split packages? Some reasonable number of hands. A split package is when multiple loaders define classes for the same package. Remember that a module can read at most one other module that exports P. That's baked into the definition of a well-formed module graph, no reads edge. If X reads Y that exports P, then X cannot also read Z that exports P. And so if loaders respect readability, the loader for module X will delegate to exactly one loader, class loader 2, for types of P. That means no split packages out of the box. That's a very good thing. Unfortunately, there are libraries out there which include types from packages belonging to Java SE. That means a split package, which traditionally leads to class cast exceptions and entire JavaOne talks about how to avoid them. If a third-party library that included some types from a Java SE package was to become a named module, then the module system would detect that the module exports the same package as some Java SE module. The module graph wouldn't be well formed, and the boot layer couldn't be created. But if this third-party library is in the unnamed module, then the module system doesn't detect the split package. This is because we don't want to scan every jar on the class path at startup just in case there's a package that's split across named modules and the unnamed module. The results in this case can be rather surprising, and I want to present two scenarios that demonstrate this. One scenario is a jar file on the class path that contains non-standard types in the JavaX annotation package. On JDK 9, these types will be ignored because the Java SE module graph already has a module that exports the JavaX annotation package. Any code on the class path, in red, which relies on non-standard types, even if it ships them, look, it's got some of its own, will get a no class def found error because Java SE doesn't have MyNO1 and MyNO2. Now, this no class def found error sounds bad, but it means we avoid a split package as soon as it would become dangerous. That is much better than the program running with two distinct versions of JavaX annotation, because that can generate errors at almost any point in the program's lifetime, and those errors are famously hard to diagnose. Let's go, this scenario is actually almost easier when you go through it in detail. So, many years ago, JSR 305 proposed annotation types to help with defect detection. The famous ones are JavaX annotation nullable and JavaX annotation non-null. Guava supports them, despite JSR 305 never finalizing their semantics. Now, the JavaX annotation package is actually owned by JSR 250, Common Annotations for the Java platform. There's a module dedicated to JSR 250 called Java Annotations Common. It exports the JavaX annotation package. So guava.jar comes along on the class path, expecting to find this nullable type. And thanks to JSR 305.jar, the unnamed module contains the JavaX annotation package. But the module system doesn't notice this by design when the boot layer starts up. Instead, the unnamed module with the old jar files reads the Java Annotations Common module, which exports the JavaX annotation package. And there is no nullable type in that package in the JDK. So Guava gets a no class def found error. What's the solution for Guava users? One option is to lobby for JSR 250 to include nullable and non-null types in the official JavaX annotation package. Another option is to lobby for Guava to include nullable and non-null types in its own package, not in JavaX annotation. Notice these are really governance issues, not technical issues. And that's a common thing when migrating the world towards modules. Here's a similar scenario, this time with a better outcome. For many years, Jax P, that guy again, did not endorse the DOM element traversal spec from the W3C. The JDK is enormous, right? There are all these examples everywhere of little gotchas like this. So Jax P did not endorse the DOM element traversal spec. In concrete terms, Jax P included the org W3C DOM package, but not the interface element traversal in that package. So the Xerxes XML parser wanted to implement the DOM element traversal spec. So they included the element traversal interface in Xerxes.jar. In JDK 9, the org W3C DOM package is exported by Java XML. So the same package in the unnamed module is ignored. Xerxes will get a no class def found error for element traversal, just like Guava did. The happy ending is this. Jax P has agreed to endorse the DOM element traversal spec in SE9. So in concrete terms, we added the element traversal interface to the org W3C DOM package in the Java XML module. It's as if JSR 250 had agreed to add nullable and non-null to the JavaX, to their JavaX annotation package. Now, everyone who reads the Java XML module, including Xerxes.jar in the unnamed module, can access the element traversal interface. The Xerxes version in the jar is ignored, but that's okay because the interface in Java XML is up to date, it has all the right members. 2 more slides. As their name suggests, layers can be layered. When a graph of modules is resolved, it's actually resolved against a parent layer. Then, when the graph helps to create a new layer, the new layer picks up the parent. This allows a graph of modules to have dangling references, requires clauses for modules that the module system will find in a parent layer during resolution. On the left, resolution has set up not only a reads edge between modules in one layer, but also a reads edge between modules in different layers. Constructing a tree of layers in this fashion is the job of a framework, like an app server or a test runner. Layers give frameworks tremendous freedom to organize modules at runtime without upsetting the framework's traditional uses of class loaders. It's like the invoke dynamic instruction in Java SE7, a way for framework authors to interact with the VM to reify information about the shape of the program. Now, if that sounds a bit abstract, let's look at one scenario where layers help out. Layers are how the module system supports multiple versions of a module. Here, an app server has created two layers above the boot. Got the boot layer, and then two layers above that. The Hadoop layer and the JavaScript layer. Each layer has two class loaders, and each layer has the boot layer as its parent, so its modules can read Java base. The Hadoop layer reifies a module graph with Guava version 11 and Jackson version 1, while the JavaScript layer reifies a module graph with Guava version 18 and Jackson version 2. Each module graph is well formed and mapped to loaders in a sensible way, but the modules in the Hadoop layer are not aware of the modules in the JavaScript layer and vice versa. Now note, this is all thanks to an app server creating the layers. The Java command line tool you use to launch programs doesn't create layers like this. All it does is resolve the module you give on the command line, then map everything in the resulting module graph to the application loader in the boot layer. There's my app and my lib you might have had on the command line. So it supports only one version of each module. The reason is to avoid the nightmarish problems that occur when multiple versions of a module casually come into contact with each other. It's really only safe to use multiple versions of a module when a framework like an app server is in control. The takeaway is this: just as modules wrap up coherent sets of packages and interact with the VM's accessibility mechanism, layers wrap up coherent sets of modules and interact with the class loader visibility mechanism. It will be up to frameworks to make use of layers in the next 20 years, just as they have made use of class loaders in the first 20 years. So that was a deep dive into loaders and layers. Modules do a better job of encapsulation than class loaders, but class loaders are still necessary. Layers control the relationship between modules and class loaders, and assuming class loaders respect the module graph, the system is safe by construction. No cycles, no split packages. Zooming all the way out, here are the 3 key points. In SE9, there's strong encapsulation of modules by the compiler, VM, and core reflection. There are unnamed and automatic modules to help with migration. And the system is safe by construction, no cycles or split packages. The module system, in essence, is a seat belt, keeping you safe, not a jetpack. Pictures, please. Okay. There is a long road ahead. The module system is conceptually quite simple, but in JDK 9, it's associated with changes that probably won't break your code, but might break code you depend on. We've tried to support migration as far as possible, but it only takes one unmaintained library using a JDK internal type to prevent a migration to JDK 9 if that library can't migrate, nor can anything on top of it. So in this regard, modules are unusual. They suffer from a tragedy of the commons, whereas most big features like generics or lambdas let people opt in at their own pace without needing to wait for others. You can see we've done a lot to be flexible, but one unmaintained library using something internal and you have a problem. So we've come full circle. The day started with a prepare for JDK9 talk, and here at the end of Under the Hood, I'm talking about how you can prepare for JDK9. Please try JDK9 with Jigsaw. There's the URL. Run your applications on it. Run JDEPs on your code and on the jars on your class path. And subscribe to Jigsaw Dev at OpenJDK to see common problems and solutions. Please tell us what you're finding. Lots of other talks. Tomorrow, 8:30, the hack session. And then repeated on Tuesday, Wednesday, and Thursday, the first 3 talks in this series, effectively, of modularity talks. Also, I'd point at 2:30 tomorrow, Hans Doctor from Gradleware talking about solving the puzzle with Jigsaw and Gradle. And Paul Sandoz in the afternoon talking about Sunmisk Unsafe. Crazy, crazy things there. Also, Stuart Marks on Wednesday afternoon, Dr. Deprecator himself, saving the future from the past, innovations in deprecation, migration, cleanup, moving forwards. It's all the same thing, right? And with that, thank you very much. Thank you for listening. We'll take questions here. Thank you for coming. I think you have to come up to the mic in the... Well, so the AV crew has mostly gone home, so I guess we can stay as long as we like.
It's still streaming.
Audio is here, but video is not. So, questions?
Jar files can not only contain classes, but also resources.
Ah.
Are they also protected by encapsulation?
The question was about jar files containing not only classes, but also resources. Are they strongly encapsulated? The current answer is yes, but there are many, many design discussions about that. Read the expert group list. You've been waiting a long time.
If I access an exported class and it returns an object of an exported interface, can I assume I can still interact with the object even though the object was not exported, as long as I treat it as an instance of something that is exported? And so
yes. The question you couldn't hear is yes.
Part 2 of that is, can I call a new instance if the thing that's returned is a class?
No. I should have said class new instance is under the same regime as field get, field set, and method invoke.
So if something is in fact a class of object, I can't call new instance on that. If the object...
Right, if the class object represents a non-exported thing, you can't new instance it any more than you could new the class.
Thank you.
Yeah. The question that I knew someone would ask is, all this accessibility stuff, blah, 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 what if I just, the thing that returns logger, what if I just call that method and assign to object? Does that work? And the answer is yes, because the language is very clever and lazy about access control. And as long as you treat it statically as something that's safe, everything compiles, everything runs.
If module X exports package to module Y, can module Y require public on that package? Is it effective?
Say that again? If
module X exports package to module
to module Y, yes, okay.
Does module Y, can it requires public on that package?
You don't require public on a package, you require public on a module. So
okay,
Y
requires public on the module.
Oh, Y can require X, Y can require public X. There's no problem with that. Y, in fact, it's a feature. Y is going to require X, and maybe the API of module Y uses types from the other module. That's a completely common situation. So it's quite common that module Y would require public X to push up the X dependency to its consumers. So frankly, its consumers might see a package from there, and it becomes the job of the system assembler or the higher level developer to figure out what idiot has got too many dependencies. What idiot? It's as simple as that. Next question.
What are the performance implications?
What are the performance implications? That's a talk we didn't submit. The answer is that, I mean, there is so much to say about that, and I'm not a performance guy. The accessibility checks that you saw, where the VM is seeing one type trying to access another, the good news, and the accessibility depends on the readability. The good news is the module graph is immutable. So the VM, when it gets its copy of the reads edges, can optimize and make a nice table, and I believe it does.
Assume the access check disappear in the noise.
Yeah, those accessibility checks, they're a no-op. in performance terms. Because all of the module requires this guy, requires public, so he reads him, and requires public. You can set up a whole chain of these things to refactor. The VM knows all about it, knows about all of that to start up.
Okay, thanks.
Basically, layer creation, same thing.
So you mentioned a module cannot import two modules with package B.
That export the same package, yes.
Right. Export the same package B. But what if the root module monkey patches a class, say, from Goa, right? Is that possible? Because it's not importing the module, in any module, it just monkey patches.
So, I mean, the monkey patch term is making my hair stand on end, right?
It's not a commonly used term.
No, it is, and it should make your hair stand on end as well, right?
So it's a monkey patch is a very serious tool, right? I mean, it's used a lot in reality. It helps a lot, right?
So the question is, what if you almost accidentally put a class into a module?
No, I'm sorry. So I want to fix a bug in Goa, say.
In Goa,
so I copy over a class of Goa and fix the bug locally only.
In your module?
In my application, in my module.
In your module, and you export that package?
No, say I don't.
Oh, you don't export the package?
Imagine I am the root module.
Okay.
So then I'm not actually importing...
-x patch.
I'm sorry?
Yes, let's go with yes, you can do that.
I can
yes,
do that,
you can
so
do it,
I
yes.
can still monkey patch.
If you make a line flag, you can do that.
Okay. One more question,
Yes.
if that's okay. Automatic depends on the names of jars now.
Yes.
That's crazy.
I know. What else can we do? I know.
Do you have a better suggestion?
No, I don't know. But that's going to break stuff.
We could just make migration hard.
Yeah, that's going to break a lot of stuff.
I would be totally happy to delete all the automatic module stuff. By the way, challenge. If anyone can find me a module system that supports migration as sort of a first-class feature, where there are such things as modules and also such things as not modules, please let me know about it. None of the JavaScript module systems, and there are so many, let you do that. Other module systems on the Java platform, you're either in it or you're like a loser. And so this automatic module thing, I don't want to say it's a hack, that's genuinely unfair, but it's a pragmatic answer to what do you do when you're building up, look, we've got JDK modules, JavaFX has been modularized, and there's something you depend on that is well-formed, they're pretty well-formed, and you want to require it, and you want to use all of its public types, but it's not a module. Well, to keep things consistent, I have to say it's a module, or none of the access works.
One of the best practices for everyone to do open source or otherwise is suffix the version to the names of the jars, right?
Right. So versioning in module name is a real issue, and that's sort of a separate point, which I can probably agree with you on. But the fundamental extract the GUA VA parts, I don't see any other way around it.
Got it.
But yeah, on versions, fair point.
Just to follow up, the root module is the one with the main class, right?
You say root module, and we have a particular meaning for root module.
Right.
Yes, let's go with yes. Yes.
So you've mentioned that reflection will take note of and honor all these module boundaries.
Yeah.
Method handle lookup.
Yes.
Does the security checks at lookup time rather than invocation time?
Yes.
Are we going to see terrible uses of this?
Right. So method handle lookup now does the security checks at method handle creation time, having not done so to begin with. Now we can't change. Here's the thing: we can't. There's lots of code out there that creates, looks up class objects and passes them around, right? I don't know what that code is doing. So class creation time, the time when you get the capital C class object, you could, in get class, have a whole bunch of checks. We've chosen to do it as lazily as possible, like the VM does. So you can pass these class objects around just like you're doing today, and only when you actually go and touch a field, it might be a public field in a public class, but of a package that's not exported, it's an internal package, only then, at the latest possible time, that's the general VM approach, as lazy as possible, and core reflection's pretty close to the VM, do you get the error. But sure, we could have done it at get class time. Oh, lots of questions.
If I have something in the unnamed module
Yes.
that requires a named module that has not been added on the module path, is there a way to get around that at runtime, or does it have to be specified?
Well, so the unnamed module doesn't explicitly require anything, right? It reads whatever there is for free.
Sure.
So if you have built yourself, for example, a JDK image and forgotten to include a module with useful types in it that glassfish.jar was rather hoping to use, glassfish.jar will just fail with a no cluster. I mean, the classes really aren't there.
Okay.
So all the readability stuff can't overcome the fact that the module you want to read isn't there. Yeah.
Mods to bring it back in.
Yeah. Let take another question.
Imagine you're running only with ClassPath on JDK9, so
Okay.
everything goes in the unnamed
Yeah.
module.
Yeah, that's fair.
In that case, which named modules does that unnamed module actually depend? Every named module within the JDK?
Yes, and on the so reads. Hang on about this. The reads edges, they're kind of virtual, right? They need to be present if you ever try to access something in order for the access to work. When those reads edges are set up to everything in the image. And by the way, I should say these named modules. I mean, some of them are in the JDK image, Java base. Some of maybe JDK Java doc is on the module path.
So everything that is a named module
Yes.
within the module path itself?
It's really within the module system, whether it's on the module path or I'm going to give some more details away. The upgrade module path. Right, which we haven't talked about at all today, but wherever the named module is an implementation detail, right? The unnamed module reads all named modules. That's how accessibility, a simple rule for accessibility can always work.
So if for instance, say we go to JDK 10 and God forbid you're still only using ClassPath, and
Okay.
one of the libraries in your class path gets merged into the JDK into a named module.
Okay, yes.
Your code will no longer work at all because you are not explicitly naming that module, but you're not picking it up either.
Oh no, that's sort of the Guava example. If there is some package that gets pulled into a named module, either in the JDK or...
but when I run my application, I
Yes.
do not explicitly say I need that module.
Right, because you're still running in JDK 10 with the class path, and you've still got some jar on...
So the module is automatically imported
by the unnamed module, and whatever that module that's got the new stuff in JDK 10 exports is what stuff on the class path, code on the class path will see.
Okay.
So things, if anything, I mean, it's the moral equivalent of this Guava situation. Here we are. Yes. So, there is today, it is a true fact, there is a module that begins Java that exports this JavaX annotation package. And there are more types in that package hanging around in a jar file on the class path. It's true today. If those two annotation types move into the Java module, that's great. I mean, it's not great for our footprint.
That should work.
It will work.
Okay, so I think I found a bug in the current Jigsaw build.
Totally possible.
Yeah. Thank you.
Okay.
Hopefully this is a little bit more straightforward.
The thing and the thing need the thing and the thing. What if the thing is like the thing?
So the module info.java
Yes.
really seems like a buffed up version of what would normally be contained in the metainf directory. Do you intend to do away with manifests?
So there's more in a manifest, sealed packages and some weirdo legacy version information than you can express, basically legacy stuff. There's more there than you can express in the nice clean module declarations. So if you have a need for some of that legacy stuff in a manifest, it will keep working and JavaLang package will continue to export that manifest information, sealed package, blah, blah, blah. But the most useful parts of the manifest basically translate into module declarations. Including the metainf services files, which we haven't talked about here at all today because we need like another dimension of Jigsaw talks. So basically, the manifest, it will still work. There's nothing wrong with having it in your jar file on JDK9. You can have it alongside the module declaration, but the module system will only read the module declaration in module-info.class.
Do you intend to eventually move away from manifest altogether? Is there something the manifest can do that a module info.java could not?
There is an example of that today, which is the main class, right? Which you can't specify them. You can specify the main class in the manifest, right? Yeah. Right, but you can't specify the main class in this here module declaration. You specified it.
But it can be in the description.
Right, so when you build your jar file, you can nominate the main class, and it gets recorded in the jar file, but you don't say it in this source file. And the blank look on your face tells me, which is completely reasonable. A lot of people say, why aren't there version numbers in this module declaration? Why isn't there a main class? There's actually more stuff than we're showing you, but people don't care about that. Why can't I put this other stuff in there? We're trying to keep this module declaration very simple because it is read by all those compilers, which need to figure out the module graph to figure out accessibility at compile time. And stuff like main classes and authors and what license the module is using and so on, compilers don't care.
Sure.
But the VM doesn't care. And so that's why I say the module system is much less about code and it's much more connected with the tools ecosystem that do care about those things. And the way the tools and this stuff will work together remains to be seen. We're working with Hans and Jason and yeah. Thanks for, yeah.
Two very easy questions. First one is you can only export at a package level, correct?
Yes, you can export a package.
Second one is, will all this information be available via reflection?
Yes, JavaLang Reflect module and indeed JavaLang Reflect layer tell you everything you need to know.
So speaking of reflection, how would a dependency injection framework that uses reflections handle a modularized system?
Someone asked exactly this question about DI framework. So the issue is really that the non-exported packages are locked away. And if the DI framework wants to either bind classes to interfaces that are locked away or use as implementation classes stuff from the locked away packages, frankly, it's got a problem. So there are a couple of things that can be done. One is, this is not a command line oriented talk, but you can always on the command line override module declarations -x at exports because it's your machine and you're in control. The other thing you can do is a module that exports, I should put an exports thing up, a module that only exports, so MyApp, good example. MyApp doesn't export anything. It's got a main class and it requires a bunch of stuff, but it's not a library, right? But it wants to benefit from dependency injection. So what it can do is it can export certain internal packages to the dependency injection framework. I haven't shown the syntax. It's basically export something to spring.di, or to juice, better example. It's kind of straightforward, and you say, well, why should I have to say that? And the answer is you're making your intentions clear. You're declaring what you export to everyone, which is probably nothing in this case, and what you export to your friends, so the VM can enforce it. Last question, I think.
Automatic modules, are they a specific thing of the boot layer, or can they be...
That's a good question. Are automatic that's not quite the question I thought you would ask, but are automatic modules sort of an implementation feature of the boot layer?
I think TBD for the GSR.
Yeah. Automatic modules, quite how standardized they are, and therefore whether they only exist in the JDK or in other implementations.
Because if you have a story for migration on the class path end, what about application servers?
So
current implementation, they can be anywhere, any layer.
They can be what?
Any layer.
So, okay, so what about, someone asked earlier today, what about, we've spoken about modular jars, what about modular war files, modular ear files? How will CDI arrange for dependencies to be set up? All of those Java EE questions remain to be answered by the Java EE 8 expert group and beyond. So it's a completely fair question. How will app servers take advantage of this? I mean, there's the question of how they modularize themselves just to protect their own internals, And then there's a question of how will the various EE standards take advantage of module declarations and services and all the other stuff we don't necessarily show. The ball has only just started rolling.
Thank you.
Thanks. I think that is it. Thank you very much.